Okay. Hey, everybody. Welcome to Advanced Programming with Java here at Portland State University. I'm David Whitlock. I've been teaching this course for a very long time, and I am super pleased and excited and proud to be coming back once again to experience some Java development with you, learn about some advanced programming techniques, and hopefully give you some experience with some things that maybe you've been curious about, maybe you've always wondered about, but haven't gotten able to really exercise and work with in as part of your studies. So we've got a bunch of stuff to cover tonight, and let's just dive into it. So, and people are still joining us. So today on the agenda, first we'll have some introductions. I'll say a little bit more about myself, and we'll introduce the graders. And then we'll talk about the course and the syllabus. I want to give everybody a good idea of what to expect over the next 8 weeks. And then I want to take a minute to do a group activity. We'll go into some breakout rooms for everybody who is remote to learn more about our experience with learning remotely. You know, we've all been doing this for a while, but things keep changing, right? We have the opportunity to be back in the classroom. You know, no one's wearing masks anymore. It's different, and I would like to hear what your experiences are and how they've evolved and sort of where your head's at now in terms of things that work, that are effective for you and things that are ineffective for you when it comes to remote and now distributed learning. And then we'll start looking at some Java code. We will take a look at our first Java project. And this is an activity that I'll be doing for you, and you'll have an opportunity to do it on your own too, to start getting used to the tools, start getting used to the language, all that good stuff. And then we'll talk about something called the Java Koans, which is a teaching tool that I use to have people learn the Java programming language. We'll talk some more about test-driven development, and in the remainder of our time, we'll talk about TDD, test-driven development, in a Java project. I was going to warn you now, this first night is going to be long. We'll probably go right up until 9:30. That's unusual. The first couple of weeks are like that. After a while, though, there's not as much content, and quite frankly, I get tired after a couple of hours. So don't worry, we'll take lots of breaks along the way. We'll make sure to pace ourselves because you know, I know it's a lot for you to consume and to pay attention to. So I want to make sure that we can get through all of it and feel good about the outcomes. So I want to introduce myself and the people who will be supporting you this term. I'm David. Once again, I'm David Whitlock. During the day, I work as an engineering manager at a company called Tripwire. We make cybersecurity software. I've been with Portland State for over 20 years now, which is kind of crazy. And I've been teaching this course the entire time. I've been really lucky to be able to make this course my own. I'm really the only person who's ever taught it, and it's evolved quite a lot over the years. And every time I teach it, I like to add just slightly tweak some content, provide some tools to make it a little bit more approachable, so that the maximum number of people can learn and derive benefit from what we're doing. So I'm really excited about this summer. Thank you all for joining us. We have two guests that are here tonight who are our graders. It's Yizhuang and Jaeger. If you wouldn't mind coming up and introducing yourselves. Yizhuang, could you go first, please?
I can go first. Hello, everyone. My name is Yishan. I'm a grad student from China. I'm looking forward to be your grader this term. I took Java last winter, and it was a great course. I love it. So good luck.
Thank you. Appreciate that. And Jaeger?
Hi, everyone. My name is Jaeger. I took Java last summer, and it was one of my highlights for the summer. It's a really amazing course. Dave teaches it really well. I enjoyed the Java Koans a lot, and the projects just kind of build on each other. And as long as you keep up, it's going to be a pretty straightforward class, and you learn a lot of things. So yeah, I'm really excited to be here and to be reviewing some of these concepts with you and to help grade and go over your projects. Thanks.
Great. Thanks a lot. And so these two are graders. They will help us provide you with feedback during the term. Just to be clear, these are not TAs. They're going to be holding office hours and things like that. We'll talk about how to reach out to me and to reach out to the other students to learn more about the course. But when it comes to the quizzes and the projects, they'll be helping me out a lot to make sure that you can get good feedback in a timely fashion. Cool. Okay. So, let me move some of these windows out of the way so people in the room can see it. So this is something I did. Oh, looks like there are some questions that have come in. I'll get to those later. So both when I taught in the winter and now I'm teaching now, I had the option to make this what I call an attend anywhere class. You know, everything that we've been experiencing for the last 2 years has really taught me that the most important thing is our safety and our health. And I want to make sure that each of us has an opportunity to engage in class in a way that makes us feel comfortable and that allows us to live the rest of our lives in a way that's effective for us. So I've classified it as attend anywhere, which means that you can come to the classroom here, and thank you to the 6 of you who have. That's 6 more than I had last time when I taught, so thanks. However, you're not required to be here. You can also participate remotely. So if you're in a situation where Zoom works better, great, be on Zoom. And you can go back and forth. So maybe this week, yep, it's in the classroom. Next week, oh, hey, you got something else to do, or you just, don't have the ability to get here at 5:30. That's totally all right. Feel free to attend remotely also. But everything happens live at Wednesdays at 5:30. That being said, this is still a collaborative course, even starting tonight. We'll be working with other people. One of the things I feel really strongly about is that software engineering and coding is a team sport. And so we'll be seeing that in a number of ways this term. And so then, when you're on the Zoom, expect that you can work in breakout rooms to do some collaboration activities. I also use Zoom for office hours, which are the hour before class. Please reach out to me if you want some Zoom office hours. I can accommodate other times too, but sort of like the published times are an hour before class. I've also made the lectures and are available on YouTube, and so I have a bunch of lectures that I recorded years ago that are still relevant, and so they're up there on the YouTube channel. And actually, all of this is available via the class's website, which I'll post here in the chat. Class website, so go ahead and check that out. That is meant to be sort of the landing page for everything you need to know about the course. So there are links to the YouTube channels. I'll also record. I'm also recording this class session, and I will try to get that posted up to a separate YouTube channel by noon tomorrow. So that you can go and review it. There might be a section where you're like, I know he was talking about that one thing, I didn't quite understand it, or maybe, gosh, he was talking so fast, or maybe I fell asleep, or whatever. Go ahead and the material is available to you. Also, when it comes to the work, there's only a couple of work that must be done in real time. Everything else, including the quizzes and the exams and the surveys, are done through Canvas. And then the projects and stuff are submitted. So all that work is asynchronous. There's only a couple of things that require you to be engaged at a certain time. And then I'll also leverage a Slack channel to do day-to-day communication. And so this is like announcements that I have, or if you have a question, please post it there, and I'll try to check it at least twice a day, usually first thing in the morning and then the evening after work. But then also it's an opportunity for your peers to weigh in on your question, or if you have a good idea that you want to share, you can engage them in a conversation there. So that's how Attend Anywhere works. Oops. Accommodating. I'm pleased to say that the course is popular and it's registered almost full this term. Ironically enough, this classroom, which I love so much, is my favorite classroom in the entire campus because it has these stations around it where you can pair program, where you can mob programming really, really well. Only allows 50 people. which is like, this is a huge classroom. We could, there are classrooms that seem smaller that allow more, but this is the one I want. And so that means that the maximum enrollment in the class is 50 people, even though it's attend anywhere. So it's filling up. I think we have enough room for everybody. But if there is anybody who is on the line, or if you know of anybody who wanted to register for the course and hasn't yet, I'll try to accommodate you as best I can. And so I hope that despite this being distributed, but despite the attend anywhere and the fact that there are a lot of people here, I hope we can provide you with a great learning experience. As you heard from the graders, both of them have taken the course before and liked it enough that they're dedicating their time this summer to help us give you a great experience as well. So let's see here. I saw a couple of questions that came in over the chat. I'll get to those, and if there are any other questions, please raise your hand on Zoom or raise your hand here in the classroom. Let's see here. The first question. Hi, David. I use a collaborator on my PSU GitHub. My username is not my name. Can I email you if you'd like to have that info? Oh, yeah. Don't worry about if your GitHub user is not the same as your PSU. We'll talk about how all that works pretty well. Let's see here. Are there any features in the community version that are not in the subscription version of IntelliJ that we needed for this class? I think the GitHub integration might be a lot better in the professional edition. And given the fact that it's free to all PSU students, I don't see a reason why you wouldn't want the ultimate edition. But we can give the community edition a try and see how it works for you. Couple questions there. Okay, any questions here in the classroom before we get started? Yeah. Question is, are the slides going to be available? Yes, they're available on my website. Oh, and these slides right here, actually, this is not important. The real slides they're all here on the website. And so what I encourage you all to do is to go through and review the slides or watch the screencast before class. To give you a little bit of context. Of course, here the first night, you'll have to do this afterwards if you haven't done it already. But yeah, here we have all the slides, and these are covered in the screencast here on YouTube. This is me talking about JUnit right here. Okay. Oops, I think I'm the only person that can hear that. Okay. Other questions? Nope, nothing else. Okay. Let's talk about the syllabus and the expectations for this course. So what I hope to be able to, what I hope that you accomplish and get out of this course is an appreciation for the Java programming platform, all of the things that can be done, ranging from writing command line programs to doing unit testing to writing a distributed client server web application to doing Android programming using the Java programming language and the Java programming platform. And I hope it's a fun experience for you. Right, we're here in the summer. I hope the class is engaging and that you get to experience some things that you haven't experienced before. Now, there's a number of ways in which we learn. I acknowledge that different people will learn in different ways. So there's what we're doing right now, which is the in-class discussion, the in-class exploration of programming. But there's also lectures that are online, like we just saw with JUnit. And then we'll also be working together in mob and pair programming during class. I'll speak more to that next week to give you some more details there. You'll also be seeing a lot of code in this course. There's the code that I write in front of you. There's the code that's mentioned in the lectures. There's a code that's available in my GitHub repository. Hopefully through that you can see how Java programs are structured. You can get an idea of how you use the various APIs and language features. On your own, you'll be working on a multi-phase project that's built up over the course of the term. We'll get the first assignment tonight. That'll sort of be laying the foundation, doing the basic stuff, and then each week we'll be adding a little bit more to the project, culminating in an Android application that, let's see here, this term models a phone bill, I believe. And then also there are the quizzes and exams. This is what tests you directly on your knowledge of the content, and we'll see a little bit later sort of the weighting of the projects versus the quizzes versus the exam. So that's how we're going to go about it. Things that we're going to cover, you'll be exposed to the Java language syntax. So I think probably everybody has seen a little bit of Java, I hope. It might have been a while, though, or maybe just felt you scratched the surface. We'll be digging deeper here in this course. We'll also be seeing a lot of object-oriented design and object-oriented programming. So Java is an object-oriented language, and so the unit of program is an object. And you'll be writing your own classes and instantiating your own objects, and you'll be using a lot of classes, interfaces, and other APIs as part of your projects and the code that you write. We'll be looking at a lot of the standard Java class libraries. So then even though you will be writing your own code, you won't have to write your own linked list. Aw. Yeah, right. You've been there, done that, and someone who is probably much smarter than anybody in this room has written like a really great linked list. You can use theirs. Yay. Don't have to write your own. But you'll be seeing, how to do data structures, how to do I/O in Java and with the Java flavor. Something that I emphasize in this course, because it's just a part of software development, is automated testing. And so then starting tonight, we'll be looking at how to write unit tests for Java, doing test-driven development, writing your tests first, and then deriving your code from those tests. And then we'll also be using Maven to build our projects. Projects in this class, the code bases, they're a little bit more complex than maybe what you've seen before. It's not just like one class with a main method. There are dependencies. There are tests along with the code that's under test. And by using Maven, everything sort of fits together nicely, and a lot of the heavy lifting is taken care of for you. In the second half of the course, we start exploring more advanced topics like web application development, and so we'll be developing a client-server, a client to a REST API, all in Java. We'll be seeing a little bit about dependency injection and how you can decouple the classes and the objects in your program so they can be tested and reasoned about independently. And then the course culminates with a couple of weeks dedicated to Android development. So writing applications writing applications with graphical user interfaces that are deployed on small appliances. It's a lot to cover in 8 weeks, no question. But lots of students have gone through the class. They've told me that it's challenging at times, but it's kind of a good burn, if you will. I want to talk about some of my grading policies. Of course, this is important to everybody to understand how things are evaluated and what's emphasized. The bulk of your grade is made up of your project work. And so there's the multi-phase project, which we'll talk about later, is also the Java Koans. This is the code that you write and that you submit for assessment. And this is built up over the term. Because this is a program-intensive course and because it's a course about programming, this counts for 60% of your grade. The remaining 40% comes from a couple of places. The first one is that there are 8 quizzes, again, all given online using Canvas. Each one is worth 3%, and I dropped the lowest grade. So there are 7 quizzes that count, and that's 21%. We also have activities in pair programming and mob programming. And I'll talk more details about this later. But the assessment of that is really a reflection that you write. So you reflect on your experiences pairing and mobbing. And each one of those is worth 3.5%. And when it comes to these, there will be 2 opportunities to pair program. I think it's weeks 3 and 4, I can't remember. And then another 2 opportunities to mob program. And you must participate in one pair programming and one mob programming, and then reflect on that. I encourage you to do both. It's good experience. It's good coding. It's coding with people. That's not D2L anymore. Sorry, that's Canvas. And finally, the final exam is worth 12%. So when it comes down to it, the final exam really isn't worth very much when compared to the other things. So if you're one of these students that slips off during the term and then wants to make it all up in the final, it's not going to happen in this course, and they do that on purpose, right? I want to make sure that everybody's engaged and is learning along the way and is not looking for the final exam to pull them through the term. So that's the work and how it's assessed. A couple more policies. So when it comes to project submission, projects are due right before class. I want you to be focused in class during class time. And you have 2 late days that can be used during the term. So if projects are due Wednesday at 5:30, if you turn it in at like 7 p.m. or on the next morning or Thursday morning or something like that, that counts as one of your late days. And then if you need another day on that project, or if another project uses a late day, you get it there. So that's the late days. Also, if you make like a silly mistake, and lots of students do it, right? They misunderstand something about like how the command line's parsed, or they have a null pointer exception that like causes every test case to fail. You can resubmit one project for regrading, no questions asked, within 1 week of the original grading. So I've asked the graders to get the projects back to you graded and back to you by Monday morning. So if it's due on Wednesday, ask them to get it by Monday morning. Then you'll have a week after that to fix the problem and submit it for regrading. Otherwise, my policy is not to accept any late work. However, hey, if you fall behind, and certainly this has been the case over the last couple of years, and hey, we're still in this thing and we're all in it together. If life happens, if you find yourself a little behind, or hey, maybe there's something that you're really struggling with, let me know. Let's talk. I want to make sure that you're successful as you can be during the course. And so I'd rather have you spending your energy on trying to get your program to work than worrying about the fact that you might be a little late or that you didn't get it in on time. By policy, I graded on a curve. In reality, I haven't had to grade on a curve for a number of years. The way most students work out is that the numeric grade that you end up with into the term is right in line with the curve and with what the PSU considers its grading ranges and things like that. So if you're like, oh, good, my average in here is an 80, that's going to be an A, right? No, an 80 is a C, and so then, or C plus, whatever it is. So, but if you have a question or concern about your grades, please bring it up to me. I'll send you a summary midterm, a summary of your grades midterm, so that you know how you're doing. I guess one other thing. So even though the content and the grading policies are the same for the 2 sections, there's a graduate section of this course and an undergraduate section. Each one is graded. Each one has its own curve and is graded independently of each other. But then again, that probably doesn't matter too much because it just fits the curve anyway. For a long time, there wasn't any cheating, and a couple years ago there was, so I got to reiterate, don't cheat, please. And I'll catch you, and I'll be very angry, and you'll get a low grade, and so please just don't do it. And the way I'll catch you is I use a tool called MOS, which was developed a long time ago. It works really, really well to detect software plagiarism, and it's smart enough to know when you've renamed variables, and it's smart enough to know when you've deleted or added comments and things like that. So please don't do it. Also, even though, hey, it's an Attend Anywhere course, you can take the course online. I'm not sitting there looking over your shoulder to see what you're using for resources. I just want to be clear, you may not consult any online resources, so you can't Google answers, you can't look up API docs, you can't go on Stack Overflow, or any other materials, any offline materials either. So textbook or lecture notes or anything else when taking the quizzes. It's meant to be everything that's in your brain. Now, granted, of course, in the real world, yes, you can use these. This is not the real world. I want to make sure that there are certain pieces of information that you have at your fingertips that can go directly from your brain to your fingers, and that's the intent of the quizzes. The definition of cheating from the department is to submit for credit any work that you do not create or allow your work to be submitted as the work of another student. Really what I say is, listen, I want you to be collaborative on many things. You'll have lots of opportunities to be collaborative in mob and pair programming, but when it comes to your projects, that needs to be your own work. So you can sketch drawings out on things, but do not look at another student's code for your individual projects. And also, please, even though as we'll see, there's a lot, the code resides in GitHub, do not commit it to a public GitHub repository or some other public forum. Oops. I just lost my headset, it said. Hey, can people online still hear me?
Yes.
Yep.
Oh, weird. Okay, I just got a little thing in my ear saying my headset was disconnected. Well, it lied. Okay. Let me know if it stops coming through. So, so just to reiterate, because this is where we got confused last time. So some work in this class, like the pair programming, the mob programming, that is collaborative. And that's when you're working together and it's very clear that, yep, you're sharing ideas, you're sharing code, you're looking at everything like that. That's collaborative. Everything else, though, so the quizzes, the projects, the reflection on everything like that is individual work. And if you have a question, ask, please. Don't come to me and say, "Oh, I thought we could pair program on the projects because we did it in." No. So anyway, hopefully that's all I need to say about cheating.
David, I have a question.
Yes.
So for the quizzes, how many attempts we will get? It is just one or multiple attempts?
I think it's just one, yes.
Okay.
Yeah, I only want the graders to grade it once, and yes.
Thank you.
Yep. Okay. Bunch of other stuff. So like I said, everything is available via the website, and so that's the www.cs.pdx.edu/tilde-whitlock. I encourage you, actually, I say here, I expect you to have them reviewed before class, bring your questions, and refer to them as necessary. Some friendly advice: please don't wait until the last minute to start the projects. They at first might seem pretty straightforward, and maybe they are, but a lot of students have told me it's like, oh, that's a little more challenging than I thought. So make sure to start early. We'll talk more about this next week, but there's some documentation that's required for your code. I encourage you to write documentation for your code as you write your code. So if you can express it in English, you can say it in Java. Now, as much as I love to hear myself talk, I don't do this solely for my own benefit. I do it for your benefit too. And so if you have a question, please ask it. I know it can be difficult asking questions, during class, or if you're in Zoom, or if things seem to be going by really fast. But I just want to remind you that you're here to learn, and I appreciate it when you ask questions. That's good feedback to me that maybe there's something that I'm not saying very clearly, or something that bears repeating, or maybe something that you thought of that I haven't. And so I appreciate it when you raise your hand and ask for help. This is an advanced course, and no question, there's a lot of work in it. So if you're taking other courses this summer with lots of work, an operating systems course, compilers, which they don't teach anymore, but lots of program intensive courses, stuff like that, you might want to reevaluate your schedule. Make sure that you can sustainably get through the term by challenging yourself, but not overdoing it. Don't want to hurt yourself. I provide the code examples for your benefit, so I encourage you to go home, play with them, make some changes, debug them, figure out what they're all about. Once again, my office hours are an hour before class on Zoom and by appointment. So if there's something that you want, reach out to me, and we can talk offline when we're mutually available. Sorry, talk online when we're mutually available, or communicate offline. There are several ways to do that. My preferred way is to use Slack, and so I have a Slack channel. This is different from the PSU CS Slack. I like to have multiple channels, like one for every project and things like that, so I have my own workspace there. And but you can find that on the Canvas homepage for the class. So if you go to and probably a lot of you already checked this out because you found the Zoom. Here is where I just have a whole bunch of like administrivia links off to the website, the Zoom link, the YouTube playlist for this term, and here is an invitation to the Slack. So please be sure to join that. This is where I will announce things about the course. Certainly any changes in schedule, like, oh, I can't make it this week, or hey, like last year the electricity went out in the building on the last class and stuff like that. So just things like that. That's what I'll put on Slack. You can also email me with things, and so then my preferred email is whitlock@cs.pdx.edu. But please do not email whitlock@pdx.edu. This is somebody else, and his name is David Whitlock. How obnoxious! That's probably the guy with like the eye patch and the goatee and everything like that. And I don't know. If you need to reach out to me, sort of by the official PSU email, that's whitlowcd. At pdx.edu. Clearly, this other guy got there first. But here again, I think the best way and the way I will see the Slack before I see the email. Another thing about emails. When the grader sends you the email, it comes from a grader account, and there have been times where that has been marked as spam. So if you see something that says, oh, you should have a grade, and you haven't seen the grade, check your junk folder or your spam folder from emails from the grader about your project grades. There's the website again, so that's where you should get some authoritative information about the course. Very important is to run the survey program, and we'll be doing that shortly, so you can see what that's all about. But this is the thing that lets me know who you are, and also is important for creating your projects and getting started in the class. And it's only something that needs to be run once. So that's the big introduction to like the high level stuff we're doing for the course. I want to open it up for some questions, observations, ideas, hopes, fears, dreams, songs, anything. Feel free to raise your hand here in the classroom or on Zoom. Okay. Excellent. Okay, let's get started. So, GitHub. So I hope everybody is familiar with GitHub. So show of hands here in the classroom and use some reaction on Zoom. Who here has used GitHub before? It's like everybody in the classroom, a little bit. I'm seeing some reactions. Yay. Okay, good. Many people have, and that's great. We use GitHub here as a way of, well, getting experience with Git, but also getting started for the course. So I have a repository that I will I'll link here. Getting started with the course. So what I'll do now is we'll spend a few minutes going through this getting started repository. So one of the things I've discovered over the years is that many students spend more time than I really want them to just sort of getting their environment up and running, getting set up with the projects. Way back when I started teaching this, everybody had to they're writing a bunch of files. I had to be really directive about where to start. And I'm like, they aren't writing Java. They're trying to figure out how to run the command line. And they're, doing lots of Unix stuff, manipulating directories and everything. And it's like, that's not what I want the course to be about. So I've gone through a number of evolutions. And where we are right now today is that we've got this GitHub repository. And what we'll do is we'll make a special copy of this repository for each of us to do the work of the course. And I have a number of scripts that help you get started with getting everything all set up so that you can focus on doing the projects and don't have to worry so much about configuring your environment or learning how to build things. In particular when it comes to using Apache Maven on the for your projects. So the first thing you need to do to use this repository is make sure there is Git in your environment, and so Git is a tool for managing source code or really managing any files. Let's say managing source code, it sort of is emerged as the leading tool for doing so. And then GitHub is a website that hosts Git repositories that allows you to work locally and then move your code, or actually move the changes that you make to your code, off to the central repository. So it makes it really easy to move your code between machines. And of course, it's really valuable for us because it allows us to develop on our local machines and yet submit our projects from the PSU Linux machines, which is a requirement that I have from the course. Because where I grade it, I want them to be submitted, and I want you to run them on the PSU machines. So I'm not going to read all the documentation to you. I'll let you do that yourself. So you need to install the Git tools. Also, if you're using IntelliJ, I recommend that you do. We'll see that in a minute. It has really nice support for Git, all built in and all integrated into the development environment. Let's see here. We'll see in a minute that that normally what you would do is you would make a clone of my repository. Instead, what we're going to do is we're going to have each one of you create your own repository that's initialized in a special way so that it gets all of my code, but it's not an exact clone of my repository. Yeah. The question was, where do the graders grade your projects? Yes, that is on the CS department's Linux machines. That's why I require that you submit from them, and so that you can that you've demonstrated, or at least you have the opportunity to prove to yourself that yes, your code works before you submit it. Yep. Question. Let's see here. A comment about class path being a hard concept to grasp in Windows. Yes. Another question, do we have to physically go to campus and use a computer there to run the server.sh? No, you don't. You have remote access to the Linux machines, and you can learn more about that from the CATS Linux page. And so then, yeah, please make sure that you have the right accounts to be able to access these machines. And here, I'll just post this one here. That is, yep, that's how you get access to those machines. Okay, so the code that you write for this course, the project code that you write for this course, I asked you to create a private repository that's only available to you. Please feel free to make me a collaborator so that I can see your code. This often comes in handy when you're having a problem or something. I can just look at your code. It lets me reproduce things locally, and I can even suggest changes and things like that because I have access to your GitHub. So please do that. So I have some Git command lines here that are all oriented towards Unix systems. That works on my Mac here, and it'll work on Linux. Those of you who are on Windows, you might have some slightly different commands with all of this. But the nice thing about Git is that there are, you can run commands. Actually, some of the shell scripts are probably best run on the CS department's Linux machines. And then if you push your stuff up to Git, then you can pull it down onto your local machine. So, also, when it comes to authentication with Git, you need to either use SSH keys or a personal access token. You can no longer just put in your username and password. And so then, I only have limited explanation of how to use Git here, but it's nice thing with the internet. There's lots of other places that you can learn how to use the command line and get everything working for you. the whole idea again of this exercise of using GitHub, of using Git and everything is to make it easier for you. But I realize that for some people it might take you, a couple of hours to get everything working here at the beginning. But once you do, I think you'll find that it does let you go faster and make you and help you be more confident about what you're doing because you've got all of your source code under revision control. Okay, so that's using Git. So let's interesting. Okay, so let's get started with creating a repository for this course. So if you go to you're going to create a new repository in Git, and so let's see here. You do that by saying new repository. I encourage that you name it something like Portland State Java Summer 2022. Description is optional. This is something that will be there. So code that I wrote for the Summer 22 offering of advanced programming with Java. I am going to make my repository public, but you all should make it private. So please make your repository private. We don't want the source code for your class to be discovered by anybody. We will not initialize this with a README. We will not, let's see here, we will not use a git ignore, and we will not use a license, and you'll see why in a moment. So I'm going to create literally an empty repository. It doesn't have anything in it. Again, yours will be private, mine will be public. So here it is. So I've created a new repository, and GitHub is telling me, hey, there's something in there. You should go and create it. You're not going to follow these instructions. Instead, you're going to follow some magic instructions over here. Because what we're going to do is we're going to take my Getting Started repository, and we're going to make a special copy of it into the Summer 2022 repository. Oh, hey, Jonathan, thanks for posting that link about getting started with GitHub and SSH. Okay. So what we're going to do is we're going to make a clone of the Getting Started repository, but we're going to make a special kind of clone called a bear clone, which makes a local copy of the repository, but doesn't but doesn't have it point back to the repository on GitHub. So I am going to go here. I keep all of my repositories here in ~PSU/Git. You may put it wherever you want on your local machine. I'm going to copy that command there. So what that does, let's see here, Portland State Java Getting Started.git. It creates a directory there. Actually, do I cd into that directory? I do. So what I have here is I have like this bear clone, which is really just like all the guts from Git. It doesn't actually have a checkout of the files, it just has like all the revisions and all that kind of stuff, which is fine. And then what I'm going to do is I'm going to take all those guts and I'm going to push it back to GitHub to my Summer 2022 repository, which is over here. So currently, if I refresh this, it is empty. But then if I go and you do a push -- mirror to my repository, and by the way, this is your GitHub user, so I need to replace it with my name right there. Oh, I don't want HTTP. I want, sorry, I want this right here. So if you're using SSH, then you probably want to use this protocol, not HTTP. Okay, and so that went and pushed all the changes from my Getting Started repository over to my Summer 2022. And now if I refresh it, poof, I've got everything from the other repository. And so you'll go through these same steps to get yourself a private repository that has all of the starting point, all the code from Getting Started. So now what I can do here locally is I can remove the Portland State Java getting started.git directory. Oh, okay, force it. And now that I've done all that magic to get the right thing up on GitHub, I'll just make a regular clone of this repository here. Yep. And now I've got here on my local machine a checkout of my repository that has all of the changes, including all the scripts that you'll need to create your projects, to submit your projects, things like that. Some of the funny little dance that we just did with Git, some kind of advanced stuff. I've heard from a couple of you that you've done it successfully, and I hope some of you are playing along at home. Any questions about that before we start using what's in the repository? Yeah, sure. Yeah. It'll be, yeah, so, yep. Right. So the question was, hey, we just saw that we made a clone, a local clone of the GitHub repository there on my development machine. But wait, you said that everything was going to be submitted from the PSU machines. Yeah, and should I use Git and GitHub to move the changes from my local machine to the PSU machine before I submit it? Right. That was the question. Because the answer is yes, that's exactly what you should do. And we'll see an example. I think next week we'll talk about submitting, but that's exactly the workflow that you should go through. So that's a nice thing about GitHub. You can work locally, you can get all your unit tests running, you can make everything's going, and then you can push, intermittently push stuff up to Git. Sorry, push stuff up to GitHub, and then when you're ready to submit, you merely update your clone. You pull changes into your clone on the PSU machines, make sure that everything runs, and make sure everything builds okay, and then you run the submit script, and away you go. We'll see more of that next week.
Quick question.
Yes.
So does that mean we also have to download IntelliJ on the Linux machine as well?
No, that's a great question.
How are we running it?
So you'll run it using Maven, and so we'll see that shortly. How to use Maven to build your project and everything like that. So no, you don't actually write the code on the PSU machine. You instead get the code. You run Maven. That'll build your project. That'll run your unit tests. Make sure that everything works the way that you expect, and then you'll submit it. Cool. Okay, I think it's time for a break. Let's take 10 minutes. So by my clock, that's 6:27. I'm going to pause the recording, and we'll come back and talk some more about what you can do with this repository. Okay, so we're back. So at the beginning of class, we talked about the syllabus, got a good idea of what the course is for. And then we started walking through the Getting Started repository. So this is a repository that you do a special clone of, and then you've got everything you need to get started with the course. And there were a couple of questions that came up in chat right before break and during the break. And so thanks for some of the answers that were posted there. Before I move on, I want to give anybody an opportunity to ask a question, or if there's something that they're seeing which is confusing, please feel free to bring it up now and we can work through it. Nope. Okay. Cool. So we've created our own Getting Started repository, or our own repository for the summer of 2022. the next thing that you need to make sure you have is the Java development kit. So this is all of the tools that you need to compile and run and build your Java applications. So please make sure that if you're running on your local machine, you have at least Java version 11. We've verified that the code works with all versions, including the latest one, Java 18. So the way you tell is when you say Java-version in your environment, you get something that says something like, okay, I'm running Java version 17 here. Great. You can download, when you log into the PSU Linux machines, you can use the add package command to install OpenJDK 16. Actually, I'll just show you how to do that right now. So if we SSH into the PSU Linux machines, so there I'm running Java 16. That's fine for this course. And then you can configure that either if you're like manipulating your own like bash RC or whatever, you can do it that way. Java is here in /packages OpenJDK, or you can use the add package command, which gives you this visual interface. You can either click, or I don't want to install whatever that is, or you can use the down arrows to find, I believe, let's see here, it's Java 8, but also we want OpenJDK 16 plus Maven 3.8.1. So even though you don't need the Maven stuff, you do need the OpenJDK. So regardless, make sure that when you run Java-version, that you see at least Java 11. If you to install it on your local machine, you can if you have a local Linux machine, you can use whatever package manager you use. I also highly recommend Adoptium.net for getting OpenJDK binaries. On Mac OS and on Windows, they have nice installers and everything, so it configures your environment pretty nicely. Okay, so you've created your repository, you've configured Java. Now let's start doing some stuff with it. In order to record your grades, okay, sorry, back up a second. So there's like almost 50 of you. There's only one of me. There's 2 graders. I realized that in order to make this course scale, so I can offer it to as many people as want to take it, I have to automate a bunch of things. And one of the things that I automate is the bookkeeping, is the sort of the tedium and the toilsome things about recording your grades and sending you emails about your grades and things like that. I don't want to be doing a lot of clicking around. I don't make mistakes, so I want to automate as much of that as possible. And that all begins with you telling me, well, who are you? And some information about that. So I don't record all of the grades in Canvas. Instead, I use my own tool that I have developed over the last 20 years. It works really well for me. And so to tell me who you are, there is a program called, there's a script called survey.sh, which runs a Java program that gathers some information about you and emails it to me as an XML file. And it also stores that XML file in your GitHub repository, and then it's used for things like the submit.sh program and for creating your projects. And so then the first thing you need to do is run the survey program. So I'm here. Oh, and by the way, this needs to be done on one of the Linux machines, the PSU CS Linux machine, and so then. The first thing we need to do, I'm here on the I'm here on rita.cecs.pdx.edu. So the first thing that I want to do is I want to make a clone of my GitHub repository, my summer 2020 GitHub repository. Oops, which is this one? Summer 2022. Sorry. So I'll make a clone here on the PSU machine. Actually, wait a second. I'm going to make it so I only need to type that password once. Good. Now I'm going to make that clone again. And now I've got my repository right here. So I'm going to run the survey program. And it's asking some questions about myself. I need to know my name. I need to know first name, last name. You can call me Dave. Okay, and then it asks me for my Unix login ID. I need a unique ID for everybody, so I just chose this one. So mine is Whitlock, yours is whatever. Email address, you can put in whatever you want. This is what I'll use to contact you, and this is what I'll use to send your grade reports to. So yeah, please let me know what that is. I'm curious what everybody's major is. And they ask you if you're an undergraduate or a graduate. I'll say the undergraduate. I hope to learn a lot. And is there anything else you'd like to tell me? Nope, there isn't. And so then it writes a file called me.xml to the current working directory and validates that everything is correct. It is. And then it sends that XML file to the grader, and then I have another program that extracts that and adds it to my gradebook. So as you can see, it left behind a little me.xml file, which we can take a look at. It basically has all of the information that was there in the survey. This is what I use for my grading program, and as we'll see, we also use it when we create our projects and submit things. So you'll want to add that to the Git repository. And so I'll now commit that. And I said added information about me. Or actually, what I think I say, what do I say here? I say add information about myself from the survey program, whatever. So commit that to the Git repository. And then I'll push that up to Git. And now when let's see here, there is no me.xml, but now when I refresh, there it is, add information about me. And now my me.xml is here in GitHub. And so now if I were to, well, I'll come back to that later. So that's a very important first step. It tells me about you and gives you this me.xml file, which is then used to create your projects. And maybe that's where I should go next. Let's see here. What have I got next in the? Yep, here it is. Creating my own Java projects. So I get you started with the projects in that I give you the skeleton of a Java project with a couple of classes, and then what you do is you build on that skeleton and implement the functionality of the assignment. For demonstration purposes, I have what's called my Project 0, which is a simple student class which has some behavior. And we'll take a look at that at the end of class. But let's create that now. So now if I run the create student project script, this will create a project. Let's see here. Is that right? Yeah, I think that's all right. Oh, interesting. Yeah, that should be okay. So now what this does is this creates a student, let's say git status. It creates a student directory which has a bunch of files in it. So I think what I'm going to do here is first of all, I'm going to, I'll go into that student directory. And so this is a Java project for your student, and it has things like some source code. There's a student class. So this is some Java source code here with far too many lines in it, or new lines in it. And what I can use is I can use this program called Maven to, or Maven W, the Maven wrapper for Maven to build the project. So if I say Maven wrapper verify, what this does is this builds the entire project and verifies that all the tests run correctly. So to answer that question before about what do I need to run IntelliJ on the CS machines? No, I don't. This is on the CS machines. All I need to do is run Maven. This doesn't require you to install any software. Doesn't run anything with like a visual user interface. It's all from the command line. So it's gone through and built the project. And later on, we'll look at all the phases of building the project. But it went and did that and said it was successful. So that's great. So now what I'm going to do is I'm going to add the source code to Git. So I'm going to do git add the pom.xml and the student directory. That looks good. Now I'm going to say added files for the student project. I'm going to push that to GitHub. Yes, question. I did not. No, I did not copy the pom.xml. There was a pom.xml that was created when I ran the create student script. Sorry, that was an important step, I suppose. When I ran the create student script, what it did is it used something called the Maven archetype to create a fresh project based on a template project that I've created. So now I've created the project here and I've committed it to GitHub. As we can see, if we refresh this now the latest commit is added files for the student project. So I think I've done everything that I want to do on the PSU machine. So I'm going to log out of that. And now here I am back on my personal machine. You can tell, well, I guess, right? That's my personal machine. And now if I do a git pull, I'll pull down the changes that I made on the PSU machine. So I got my me.xml, I got my changes to my top level POM, and I got everything here in the student directory, all of that good stuff. So it said 10 files were changed with 904 lines of insertions. Cool. This is that Git workflow, right? You're using GitHub to move code back and forth between your local machine and the PSU machine. And because it's all in GitHub, you've got, well, because it's all under version control, you've got a backup if you mess something up. You have a backup if, like, your laptop crashes, things like that, because it's out on GitHub. And it's really easy to move everything back and forth. Okay, one more thing, and I think it's time to do that group project. Let's take a look at the source code in IntelliJ. Okay, so IntelliJ is an IDE, is an integrated development environment that specializes in Java. JetBrains, the people that produce that, also have PyCharm, which is for Python. They have CLion, which is for C and C++. I'm a big fan. One of the things that I guess I've realized as throughout my career or over the course of my career is that, boy, good tools help you a lot. I'm a big fan of tools, right? We have the computers to do our bidding, not the other way around, although it sometimes seems like, anyway. And so then I appreciate a good tool, and I believe it's worth paying for good tools. And so, like, at work, we pay for people to have nice tools like IntelliJ and fast machines and good operating systems and the right collaboration tools and things like that, so they can work faster. Right? It's an investment. It's a tool just like anything else. You want to make sure that it's sharp, and you want to make sure that it works well, and that you know how to use it and can leverage all of it. And so then you'll be seeing me use IntelliJ a lot during the term, and luckily, they make it available to free for budding software engineers like yourself. So when you open up IntelliJ, you'll get a dialog like this, which is the sort of thing, hey, where do I start? And what we want to do is want to open a project. We want to create a new one. Instead, we'll open an existing one. And the one that we'll open is the, let's see here, PSU Git Summer, Portland State, Summer 2022. And what we open up is the pom.xml file. Oops, where is it? That's interesting. I wonder why it's grayed out. Okay, I'm confused there. So the pom.xml is the project object model file for Maven. This is the thing that describes your Java project. And you can watch the Maven lecture and understand more about it, and we'll see more of it as the course goes on. But for right now, this is what you want to open in IntelliJ. And it's going to say, hey, this is a project file. It recognizes it as a Maven configuration file. Would you like to create an IntelliJ project based on this Maven project? And the answer is yes, very much I would. So I will open the project, open it as a project. And the cool thing about using Maven is IntelliJ knows about Maven, so it analyzes the project and it basically configures an IntelliJ project based on that Maven project. And then this gives you all sorts of, and I'll get rid of some of these windows here so people in the classroom can see. This gives you access to all of the information in your summer 2022 repository and in the project. So here is the student project here, and you can look at your source code. So here is where you can find your student class. And now you're looking at the source code in IntelliJ, and you can use IntelliJ to get all of the get all the information about it. Oh, by the way, sorry, one thing that you should probably do before opening up IntelliJ that I didn't do is that you should build your project using Maven. So if you don't build your project using Maven, you'll see IntelliJ complain about, like, I can't find this file. There'll be lots of things that are underlined in red. So what you want to do is you want to run a Maven W verify, which will go through and build all of your projects. And what that'll do is I'll download all of the third-party artifacts. So one of the great things about Maven is, many Java projects depend on other projects. So as we'll see here, the student class uses the JUnit framework to do unit testing. It uses some of my classes, some of the code that I publish separately for this human class, for instance, and things like that. So you can navigate to the human. Actually, I'll just do that by saying Control B or Command B. It's download the source code, and so you can see the source code and stuff for it, even though this is outside of your project. IntelliJ is really great that way, but sorry, allows you to do that. Question on the chat is a Maven verify like a Gradle sync? I don't know what a Gradle sync does exactly. I got to admit, Gradle is something I've never groked. I've invested all my time learning Maven. So what a verify does is, well, sure, I'll talk about that now. Okay. Sorry, I'm like 3 things on the stack right now. What was I going to say? Oh, yeah. Be sure to run Maven verify to download all the third-party libraries to get all of the code that you need to build the project. So when I do a Maven verify, what does it do exactly? So a Maven, sorry, I just accidentally hit Control D, and I'll just start over in a new window. Make sure I got the right version of Java running. 18's fine too. PSU, get Portland State Java Summer 2022. There you go, it's easier to read. Close that window. What a Maven verify does is it runs various phases of the project. Okay. Actually, maybe a better way to look at it first is looking at the source code. So there are several kinds of source code in this Maven project. There is the student class, which is sort of like the main logic, if you will, of the program, and so it's in a main directory. It's called source main. So that is the main code. This is like the thing that gets shipped. This is the thing that does the work, and so there's a student class there. There is a parallel directory hierarchy, which is called source test. These are your unit tests. We'll talk more about this later, but a unit test is a piece of code that tests a unit of software, so like a single class, or like some methods in a class, or some related methods across a couple of classes. And they're meant to be small scale, and they're meant to be very quick to run and quick to verify, and sort of that validate the basic logic of your code. In the IT directory, there's something called an integration test. An integration test is a larger scale test that tests multiple classes at the same time and how they interact, and usually more like at the subsystem level. We'll see when we get to later projects that integration tests can do things like start a web server and talk to that over the you have a client talk to that and everything, kind of advanced stuff. But for today and right now, just understand that there's a distinction between unit tests in the test directory, which are meant to be small little things, and integration tests in the IT directory, which are meant to test larger things. So you've got these three kinds of source code. Now, when you build this project, there are different phases. So Maven defines a handful of phases, and it's things like the first phase is, hey, make sure that your project just makes sense, that things are configured correctly about the project, that the directories have the right names and the right code is in the right places, and that I can find all of the dependencies. So for instance, your unit test here for test case uses this @test annotation, which comes from the JUnit Jupyter library. So this is something you might not have experienced before, that you have your code that depends on somebody else's code for things. You're going to see that a lot in this course, right? We leverage a lot of third-party APIs, code we didn't write ourselves, to do things better than we could do it ourselves. It's really faster than we could do it ourselves. So what the pom.xml, if you go to the pom.xml, one of the things that it has is a dependencies section. It configures all the Maven plugins. Good. And here are the dependencies. It depends on things like my examples artifact for the human class, which is the superclass of student. And it also inherits some configuration from the parent POM, which if we go to that, so command click on that, this has all sorts of things in it, including dependencies on JUnit, Jupyter. And so this is the thing then that will bring in the particular version of the unit testing framework. This is good for you to know about. And hey, if you can read this, that's great, but I don't expect you to write all of this. I provide all of this for you so you can get started very quickly in the course of having to learn all of this, like, Maven stuff yourself, and then have to apply it, right? Because otherwise, I mean, it would take a couple weeks to figure all of this out. And I don't want you to focus on how your test is configured. I want you to focus in on writing the code and writing the tests. So let's see here. Oh, there's what is this saying? Relative path of the POM. I was complaining about something. No, I can't jump to that. It's saying parent.relative path. Oh, it's got an extra space there for some reason, which is lame. Oh, there we go. Saying relative path of this POM points at this thing instead of the top level. Please verify your project structure. Right. So actually, there are a couple of other changes that I think are mentioned here in the Getting Started repository that I'm going to just go ahead and do now. So there are two POMs. There's a POM in your for your student project, and then there's one at the very top level, which is going to be for all your projects this term. And you need to go through and replace your user ID. So I'm actually going to do replace replace your user ID with my user ID, which is Whitlock. It's whatever you chose for, you added there on the survey. So it's your Unix ID. Going to replace that every place. And also then I am going to change my student pom.xml to have a parent, not of my CS410J, but instead it's going to be the parent here, whose name is Portland State Java Summer 2022. And the group ID is edu pdx CS410J Whitlock. And the version is 2022.0.0. Now, this step right here isn't strictly necessary, but it gets rid of kind of an annoying warning. Oops, it doesn't like that. Really? Wait, I need to click on this refresh Maven thing. I bet it'll like it better now. Yay, it likes it now. Everything works fine without this, but what it does is it gets rid of that error that Maven complains about. It can be kind of confusing to people. And by the way, I think I do mention this. Let's see here, parent POM. Oh yeah, here we go. In this parent POM section, you'll get a warning when you run Maven and things like that. So you just want to, you'll just want to go through and change these. Anyway, so what this does is this makes things nice and happy, and so now all the POMs are consistent with each other. Oops. And now I made some changes. Well, this is cool. Now it gives me an opportunity to show off how IntelliJ integrates with Maven. So IntelliJ in the bottom left here has a Git tab, which will show you the changes, although a lot of you might see a commit tab over here on the left on your IDE. I have it configured in kind of an old school way of keeping the changes down here. It's just what I'm used to. But what you can do is you can commit the files. This will bring up a commit dialog. And so what you can do is you can add your commit messages. It's the same thing as doing a git add on the command line and a git commit, but you can do it all through IntelliJ in one fell swoop. I find this easier to use because it gives you the diff right here, and so you can look at the changes, you can highlight the file, and you can see what you changed, make sure everything is okay. And I'll say adjust pom.xml to remove Maven warnings. And now I can go and commit, or I can commit and push, which is what I like to do. It says, hey, there are some warnings, and that's cool. And now it says, oh, I'm going to push your changes up to GitHub. And I say, yes, please go do that. And it goes off and does this for me. So, you know, as much as I love using the command line, I love using this even better. It just makes sense to me. And boy, once you see the keyboard shortcuts down and everything like that, it is super fast. So now, I just love seeing I make a change, and now it's up here on GitHub for me to see. So this is the workflow that you go through. You make some changes to your code in IntelliJ. You do things like run your tests to make sure they still work, and then you can commit and push your things back up to GitHub. All the changes there, and that way they've got it. Okay. Any questions? Oh, sorry. I still haven't answered that question about what Maven Verify does. So, if you just run Maven, it gives you this error saying no goals have been specified for this build. They must specify a valid lifecycle phase or a goal. So, Maven defines these lifecycle phases for your project. This is all talked about in detail in the Maven lecture. But for right here and now, I want you to know that there are phases that your project goes through, like I am going to compile all my code, like I am going to compile all of my test code, I am going to run my tests, I am going to run my integration tests. I am going to verify that my integration tests were successful. And then there are things like install and deploy, which you probably won't use, but that's all about I've created an artifact for my project, and I am going to deploy it off to a repository so that somebody else can use it. An important other one is clean, which says, get rid of all of the artifacts that you've built, because when you compile a Java code, you get .class files, and when you can assemble those .class files into a jar file. These are all compiled binaries. These are all outputs of your build process. And sometimes you just want to blow away and start over again. When you want to blow away and start over again, you use a clean. So what I can say is I can say maven w clean verify. And what this will do is we'll blow away all the code that's been compiled, all of the compiled codes, all the class files, all the jar files, everything that's been created. And by the way, all of those things reside in a directory called target. So here in the target has your jar files, your Java archive files that that contain your the compiled source code. It has reports. We'll learn more about that next time. It has API documentation. It has all sorts of outputs and things like that. And Matt, the reason you probably don't see that directory is because you haven't run Maven yet. So have you run Maven Verify? And after you do, you should see a target directory. You did. Are you sure? Are you sure you're in the right directory? But anyway, so when you run Maven clean, it deletes the target directory and conceptually deletes all of the artifacts that you've created. So now I have no more target directory. And now when I run Maven Verify, and I can do both, I can do a clean and a verify, that will blow away all of the results of my previous builds and do a brand new build from scratch. And that compiles all my source code, and it compiles all my unit test code, and it runs my unit tests. And actually you can see some of this stuff go by. So like there it's doing the clean, and here it's doing the compile. Oops. And it's compiling one source code to that directory, one source file to that directory, and it's building the tests. Now it's running the tests, and it gives this output saying, great, I had one test that was run, nothing failed, nothing errored, nothing was skipped. That's nice to know. And now it's building a jar file. A jar file is a collection of compiled source code in Java, and we'll see in just a moment here that that's how you run your command line program, is by running your executable jar. And creates the jar file, and then creates some API documentation, and then it runs your integration tests. And now it ran the student IT integration test. One test was run, nothing failed. That's really good. And now it verifies that, yes, the integration tests were successful, and that was it. And now you've got your target. And so one last thing, and we'll come back to this again shortly. You can run the student-version.jar file from here. And what this does is it actually runs the main method of your student class. So here's your main method, and right now all it does is it prints missing command line arguments to standard error, and sure enough, that's what happens when you run your main program, so you get this. The reason I'm showing you all this, because these are the kind of commands that you use on your own projects, but I hope it's giving you an appreciation of what Maven does for you. It takes care of all the heavy lifting of doing the building, the assembling, and sort of getting all that stuff done so you can focus on coding, and so that you don't need to worry about all the details of running the Java, Java command line and making sure that all of the third-party libraries are available to everything. Question? So the question is, yeah. So the question is like, hey, how often should I run verify? And like every time I make a change, should I run verify? The nice thing about the projects that you'll be working with, at least here in the first couple of weeks, is that it's a pretty quick build, right? As you saw, this took like 30 seconds. It probably even told me 22 seconds. It measured. In real time, it's probably more like 30 seconds. Pretty fast turnaround. That's good, right? You want to be there. We'll also see how to run unit tests through IntelliJ, which is probably an even faster way to get feedback. But yes, I recommend that you verify the changes that you're making to your code early and often. So this is the thing I like with test-driven development, and I'll talk about test-driven development here in a little while. But yeah, it gives you that rapid feedback. And Maven makes it really easy, right? You want to run one command on the command line, it goes and crunches away, recompiles all your code, make sure everything still compiles, runs all your tests, make sure all the tests still pass, and really lets you know about the current state of your code. So the question is, can you make it run faster? Is using multi or single? I don't know if the compiler is multi-threaded these days. For the size of projects that you'll be using in this, making this course, that won't be an issue. And that being said, I can't remember if the Java compiler, if they multi-threaded that or not. But certainly there are other processes that can be multi-thread, like you can run tests in multiple threads and stuff if it's safe to. But yes, it's also boy, if you've got a build process that takes like 2 hours to run, maybe there's a better way to divide up your source code or something, because are you really making so many changes, and are there so many dependencies that need to be verified each time? So, yep. Question on the chat: can we package unit tests with a build verify in Maven? What do you mean exactly by packaging unit tests? Oh, a nightly build script. Yes, you can, and but I've got something even better. Why build every night when you can build as soon as code is deployed? So I will not go into details now, but I have I have the Maven repository configured with something that will do a build. Actually, can I see this now? No. That will build the source code every time you make a change. Every time you commit a change to GitHub, every time you push a change to GitHub, something called an action runs that, what's all this stuff? Oh, this linked to the wrong place. Wait, this is getting started actions. Isn't that funny? Huh. But why did that? Okay, there you go. I don't know what I was just looking at there. That was funky. Oh, some people were making PR requests? No. Okay, I don't know what that was. I think that was a bug, actually. That was weird. Every time that I make a that I commit some changes here, this thing called a GitHub action runs, and what it does is it basically builds the entire project from scratch. And so then you can see here that there are two jobs. I run it against Java 17 and against Java 16, and then it basically goes through and it builds my Maven project from scratch. It'll run all the tests. And you can see it here downloading all of the third-party code, which isn't terribly interesting. Come on, I just go to the bottom. Here's where it was. Well, you can ultimately see that it was successful, and it built both of the projects. And so this is like super cool. So this way you get like clean room validation of your changes every time you push a change. This is something called continuous integration. We'll talk more about it next time. But the cool thing is that GitHub does this for you, right? GitHub is awesome. And so then you get this real-time feedback, and if something fails, it sends you an email, and so like pretty soon after you have introduced a change that broke something, that things are broken. So it's really powerful. Usually not a topic for the first class, but good stuff there. Okay. So before we dive into code, I want to give you an opportunity. I want to talk about. I want to change subjects. Actually, before I change subjects, are there any other questions about what you've seen so far? If anybody is playing along at home on their own machine, are you encountering any problems or difficulties that you want to work through right here and now?
Yeah, I have an issue.
Oh, I'm sorry. Someone remotely.
Yeah, sorry. Go for it.
Okay, we'll do this here in the classroom first. Yeah. Right. The question is, hey, wait, you were doing some stuff on the Linux machine, you were doing stuff on your local machine. Does the order matter? The answer is yes. So the survey.sh script needs to be run on the Linux machine. So you run the survey.sh on the Linux machine. That creates the me.xml. You commit the me.xml. Once that's in GitHub, you can create the you can create the projects on your local machine, or you can do it on the Linux machine. Doesn't matter. Yes, in order to run the create student script and the create first project script, as we'll see later in class, you need to run the survey program first and have that me.xml file there. Right. Yeah. The other thing is that while I do have .cmd scripts for creating the projects, they're not as nice as .sh scripts. They don't do as much error checking and everything. And so if you are using the .cmd scripts to create projects, you need to put your Linux user ID there. And that's error prone. I've had so many students that would be like, oh, they forgot why they didn't realize there's a Linux user ID, and they just made something else up, and it's like, then everything's broken and the grading script doesn't work. So I was like, no. I introduced this me.xml so that like everything was consistent, and that it's less headaches for you and less headaches for me. Yeah, and so the recommendation here was that, hey, might as well use the create if you don't have access to a Unix machine, so either a Mac or a Linux machine or whatever. Just create the projects on the CS department's Linux machines, commit them all to GitHub, push them to GitHub. Commit them to Git, push them to GitHub, and then pull them down to your local checkout. Thanks. Someone on Zoom had a question also.
I think I might have it. So I think I'm good.
Oh, well, actually, if you wouldn't mind asking it and maybe talking about your solution, just it might be someone else who encountered the same thing.
Oh, sure. So I thought, Leah, I thought I had the JDK already installed, but maybe I didn't. So I was trying to run Maven verify, and it was giving me a warning saying couldn't find Java-C.
Yep, that would do it.
So yeah, I just installed it and running it, and it looks like it's working.
Nice.
Also, I did do a small pull request on the thing, so I don't know if that was a bug that you saw.
On which repository?
It should be that one. It was just some missing text. Yeah, I think so.
Yeah, I think it was the getting started one. Oh yeah, it did. Okay, awesome. Thank you. I will take a look at that. Oh, and then a couple people have. Sweet. Okay. That is super awesome. I totally appreciate that. Hey, this is another thing I really love about Git, right? Is that we're able to collaborate so effectively. And so what these are is so Stephen found there was something that in the README that was probably a little, what is this? First-time contributors need a maintainer to approve running workflows. Oh, that's neat. Okay, sure, I'll approve that. So let's see what files he'd like changed. Oh, awesome. Just a little line of clarification, adding local repository. Super cool. So I'll actually, this is just pretty simple. So I like this. And so then I'm going to let the checks happen just to make sure it doesn't break anything, and it shouldn't just change the README. And then after that, I'll be able to merge these changes in and although I might wait till, well, so I merge the changes here, and then maybe I can use these as an example of then pulling these changes into all your repositories too. But my gosh, that's like an advanced thing. We'll do that next week. Oh, it looks like the Java 16 one passed. That's nice. Anyway, it's just so cool that like GitHub gives you all this feedback in real time. Oh, and there it was. So thank you so much. I am going to update the README to clarify the, sorry, what was it exactly that you changed from top of directory of your, local repository. Yeah, thank you. For where you should run the Java, from where you should run the survey.sh script. Cool. And so now I can confirm that merge. Nice. Okay. And thank you very much. And now that change is there. And I think, oh, is he not a contributor? That's a bummer because he should have. I didn't squash the commit. I thought he would be in there. Maybe it just hasn't been updated yet because there is his change. So he should be listed as a contributor to the repository at some point. Anyway, Git is neat. And you'll have lots of opportunities to work with Git both for yourself and then also with others when we do the Koans. I'm just going to turn off his stop video. You don't need that. Okay. Oh, Alana, thank you very much. The Getting Started with Java PDF is broken. Oh, I thought I got rid of that. Can you either send me an email or hit me up on Slack or something, and I'll take care of that? Yeah, the Getting Started with Java, the PDF was like old and busted, or not busted. It was like out of date, and I'm like, we talk about Getting Started with Java here in class. We don't need a PDF about it. So that was good. Awesome, good deal. I like the way it's going. Yeah, and Kyle, I'll get to your PR later. That's so cool. I appreciate the participation for everybody. That's super neat. Okay. Other questions, comments, feedback on what we've been doing so far? Nope. Okay. Switch gears, and because I want to give you all an opportunity to collaborate with each other. I'm going to create a new Google Doc because I want to hear about your experiences being remote to PSU. So, yeah, it's been a couple of years, but and I've taught throughout it. As a matter of fact, I mean, I was actually teaching here in this classroom in winter of 2020 when come February, and it's funny because I still have like the videos and the recordings. You can sort of tell week after week I'm just reviewing the introductions, and like every week it was like, well, there's this thing, and it's like, and now everybody's seeing. I mean, it was kind of like, oh damn, right? It was like really bad, and then like the last one is like, I'm at home, it's like, and no one's here, and like we all didn't know what was going on, and and things have evolved so much, and we've all learned, and I want to learn from you about what is effective and what's not effective when it comes to your remote learning. So what I'm going to do shortly here is break everybody out into breakout rooms, give you an opportunity to work with 3 or 4 other people, and to answer questions about what have you found to be effective when it comes to remote learning, and then what have you found to be ineffective when it comes to remote learning. Oops, I will fix that to be effective. And I don't know, I'll just put these in big headings and stuff. So, and then you can just add your answers here, and let me share this document with everybody. And we will say anyone with a link and edit, and I will copy this link. Sharing is simpler. Well, that's good to know. Copy the link, and please edit this document with your ideas about remote learning. So let's break out into breakout rooms for 10 minutes. And of course, folks here in the classroom, how about you form 2 groups, or approximately 3 or 4 people, or whatever, and populate this document with with ideas for what you found to be ineffective and effective when it comes to learning remotely. Any questions before we start the breakout rooms? And let's let people sign up for themselves. I'll create, actually, how many people do we have in here? We have 34, so I'll create, oh, sorry, that's what I wanted, yes, thank you. Let's create 9 rooms. 35. Sure, that'll be good. Okay. Please choose yourself. Please go into the breakout rooms in Zoom and go have a discussion about effective and ineffective remote learning. Hey, welcome back everybody from the breakout rooms. So I was watching the changes to the document go by. It sounds like some really good stuff. So here's what we'll do. I'll just go through the rooms in order. Starting with the people who are on Zoom, and then we'll have people in the classroom talk. And if someone from each room could just speak briefly to the results of their discussion, some of the highlights of what they found to be effective and ineffective when it comes to remote learning. So room 1 with Jacob, Mark, Nathan, and Susan. What did you learn? What did you talk about? And what have you found to be effective and ineffective when it comes to remote learning? Someone from room 1, Jacob, Mark, Nathan, and Susan, please come off mute and tell us what you found.
Okay, hi. Can you hear me?
Yeah, hey, Susan.
Hi. Yeah, so well, we can rewatch lectures if we need to. That's what's effective. It saves time, energy, and money from not commuting. Also, if it's hard for someone to sit, through a long lecture, then you can stand up, walk around a bit if you're online listening. Ineffective, missing out on connecting with other students in the same way as in person.
Great. Thanks. Room number 2, Jacob, Jihui, and Lakshmi. Could someone come off mute and offer what you learned? Jacob, looks like you came off mute.
Speaking, I guess I kind of blew up which of our inputs were our room. That was me, sorry. If I could just use a little bit of recall. I think what we said for pros was access links easily at the top, better offline materials, a lot better time for when you're offline for juggling between work hours and class hours. If we have jobs, lower cost of tuition and transit money. The pre-recorded lectures are amazing. I don't know, it seemed like they were much less available before COVID versus after COVID. And then for our cons, distraction, I don't know if that was our room or not. Generally less engagement from classmates, less interactions with classrooms during lecture hours, etc. Group projects as final exams are abhorrences, and there are lots of audio and video problems between how much preparation professors have and instructors have. Sometimes you have really bad audio visual quality.
So wait, a group project is a final exam over Zoom?
Well, just
that thing?
Not over Zoom, but
okay.
In lieu of a final exam, that we would just have one big group coding assignment.
Right. Huh. Okay. Yeah, that's yeah. So folks here we're talking about here in the classroom we're talking about their experience with group projects, and yeah, it brings back all those horrible memories. I can say is that it almost always gets better once you're out in industry and everybody realizes that it's like, I'm not going to be able to eat if I screw up. So people tend to be a little bit more forthcoming. And yeah, cool. Thank you. Excellent. Thanks for sharing that. Room 3, Anna, Ben, Dylan, and Tacey. Someone come off mute and talk about what you discussed.
Oh yeah, hi. So we have some overlapping like pros and cons with the other groups as well, included like for pros it's a shorter commute, like more resources as far as probably pre-recorded like lectures or recorded like lectures that is people that allow people to like easily get back to. And I also found like that is a little bit less distractions from other people instead of like sitting in a room with like 40 other people and people talking over each other or like asking unrelated questions or opinions. And it allows the instructors to like set aside things that he will cover later in the lecture, or yeah, it's to save time doing that. And then for the cons, like another student in our group is taking grad, and she mentioned that it was like a little annoying when she did the capstone like the first half before the pandemic, and then during the pandemic, like during the first term of the capstone, transfer to like remote, and she had to like adapt to like learning doing things remotely, and it's annoying because she was like a lead and had to like navigate and figure out why people are not showing up and not like participating. That's another cons of doing remote.
Cool. Yeah. And it's interesting what things are similar across various people, in which things are different based on the class and based on the individuals who else is in there. Nice. Thanks for sharing that. Room 5, Chinmay, Joshua, Matt, and Nicole.
Hello. So for our group, one of the things we had that might be a little different from what others had, looks like there's a lot of overlap. So one thing that we talked about is we said, yes, we know like over Zoom and stuff, there's less interaction between the students. You might be face to face, but when you do stuff like create breakout rooms and give us little groups of 3 to 4 people, it actually just kind of create a social environment for us to mitigate the effects of just being online. And with our group, I felt like we got a lot closer talking. And even one of our group members, Chin Mei, was like, hey, I enjoyed conversating with you guys. I'll probably get your contacts later on. So I felt like we might not be seeing each other face to face. In fact, none of us even had our videos on, but we became friendlier and we're excited to work with each other for sure. So I feel like just, yeah, so that's the thing. And then for something that's a bad effect of being online, I even called myself out. I was like, we're too comfortable at home. Like, cause right now I actually have like some snacks on the side and stuff. So it's like, you can be way too comfortable, but where I was in person, I'm just paying attention to the lecture. I can't go get up and pop some popcorn or anything, I have to just be taking notes.
Yeah, it's different. And, there's nothing wrong with being comfortable, right? There is a line between comfortable and too comfortable. Yeah. Excellent. Thank you for sharing that. Okay, let's see here. Room 6, Caleb, Rakana, and Richard. Anyone from that room like to come off mute and tell us the kind of things? Oh, let's see here. Oh, Caleb, looks like you came off mute. If you're speaking, we can't hear you.
Oh, sorry, my mic was turned off, I guess.
There you go.
I was just giving a whole explanation, and
and I'm sure it was awesome.
Yeah, no, I had to
so all your stuffed animals are probably just like applauding, but
yeah, they were. But we talked about some of the same stuff with like lectures being pre-recorded. We also talked about how the professors have the ability to like control over the class and being able to mute people and like manage like a classroom setting. And then for the cons, we talked about how it's easy to get distracted. Like, in fact, I think we got distracted. We didn't even talk about like this for like half the time we were talking. We were talking about some other stuff.
Nice. Yeah, we've all been there. Room 7, Jonathan, Shrestha. There you go. I like that. Shrestha, Tram, and Vidya.
Yes, that's Shrestha. That's okay.
Sorry.
So we were discussing on some topics like the advantage is like when we review the recorded lectures, we get the opportunity to go through the idea, which is important. When the professor mentions that this topic is really important, we can just go through over and over again when we are looking at the recorded lecture. That is one of the advantages. And it is also like we are having so many exercises in this lecture. Then when we do the implementation later on, we can just go through and check what the steps professor was taking, and we can just follow them. And it's quite easy to follow. And one of the disadvantages were like we don't get opportunities to meet the professor and the other fellow classmates as interactively as that can be done when the class is happening in person.
Nice. Thank you. I've seen some good advice coming here in the chat. Things like creating study guides with timestamps from the recorded lectures. And then a little bit of commentary about how group projects would be better if Git and GitHub were used and people knew more about them. Nice, great. Thank you for sharing all of this. This is great stuff. Let's see here. And then our last breakout room with breakout room 9 with Brandon, Leshy, and Vincent.
Our group is pretty much having the same thing that Pierre's group had talked about. First, the pros to us is that the recording lecture is helping us being really flexible, and the cons is really we'll get distracted from so many things at home.
Yeah, it's pretty easy to get distracted. Besides having flexibility, and it's good to be safe, right? And so that's what it really comes down to. So thank you, all the folks at home. I realize I don't have a good audio solution for people here in the classroom. So I guess popcorn, and I'll repeat it. It can be your hype man. So okay, so like, what are some of the things that you found to be effective that really haven't been said before? Anything that was unique about what your group was talking about? Right. So yeah, Alex has a really interesting. It is Alex, right? Okay, Alex has a really interesting observation, which is now that we're going back into more hybrid, it's not so much like, oh yeah, let's do 11:59 on Canvas, just sort of have it in whatever. Now it's more like, what I do, which is like I want done before class, and so yep, it's 5:30 p.m., not just like 11 o'clock. And so then for people who had adjusted their schedules to say, okay, good, hey, I can start, or I can finish up the assignment starting after dinner. Nope, it's due before dinner. Yeah, so that great, excellent. Other observations that people have and wanted to share.
Nice to be able to make videos, timestamp videos.
Yeah, well, you watch videos and you get the asynchrony of all of that, but then also, yeah, distractions at home. I hear that. Okay, excellent, cool. And let's see. Oh, and the folks in the classroom asked me for some of the things that I found to be effective and ineffective as an instructor. So it's teaching like from home. So I did that. Must have been summer 2020 and summer 2021, I guess. I don't remember. Anyway, but the videos up there on YouTube, you see how long my hair was? Like I went a whole year without getting my hair cut. It's gray. Anyway, so it was super convenient to be at home as opposed to like, so I live out on the west side, and so instead of having to come downtown and everything, and it was like, okay, great, I can finish up work and just like grab a bite to eat and then like go teach. I can teach in my backyard, and like this time of year, like in the summer, it was like still light out and everything, and it was just kind of novel and everything. But I had to teach in my backyard because like my family just did not want me in the house professor mode, right? I mean, imagine like living with this. I mean, come on, right? So that was also a downside. And I have to admit, I miss the interaction. I miss like there were times when I taught in the winter where there was no one in the classroom, and I'm like, this is super awkward. And okay, but but it's what we've had to do. There's a reason, and I'm glad that it's generally safe to be in an environment like this again. We all hope, but not everybody's there, and not everybody will be there. So I'm glad that we have the option of being remote. Excellent. Okay. Well, hey, thank you for sharing all of that. Thank you for working with each other. Let's take a quick 5-minute break, and then we'll come back and sort of plow through some Java development. So just a quick stretch your legs kind of break. Okay, so let's get started again. Okay, so we learned about the getting started repository, and we learned how to create our own repository. I want to now talk, and then we had our discussion about what remote learning has been like for each of us, and now I want to talk about test-driven development. So. There's an approach to software development that I really like, which is called TDD, test-driven development. And basically, in what you do in TDD is that before you write the code that has the logic for the problem that you're trying to solve, or the solution to the problem that you're trying to solve, you write some tests to express what you expect your code to do. And this is something that it took me a long time to really understand and really feel comfortable with, because it was very different from what I was taught. And it was different from how I thought I should approach solving problems, which is like, I know what the solution is, I have it in my head, and I'll make lots of sketches on paper, and I'll draw out pseudocode, and I'll do all this stuff, and poof, everything will be done. But what I found over time is that I got it wrong a lot. And it's not because I don't think I'm just dumb or anything. It's just like the problems are hard. And what I realized is that I didn't understand enough about the problems at the beginning. I ended up spending a lot of time going down like a lot of rabbit holes and doing a lot of work that wasn't necessary, doing a lot of pre-optimization. And I was like, wow, you know what? And I would break things as I would go. So when I learned about test-driven development, I said, well, maybe there's something here, because I've run into challenges before that I think will be solved by test-driven development. And it's something that over time I introduced into the course because it's really helped me in my own software development and own career, just my own thought orientation when it comes to how to approach code. So I'm going to show a video by Bob Martin that talks about test-driven development, and it talks about something called the red-green refactor cycle here. I'm not going to sign into Vimeo. And let's see here. I think I'm sharing the audio correctly. Let's see here. This, I want to go. Okay, I think I want this to go here. I'm going to start this, and I need folks on Zoom. Actually, no, I think I should have it in my ear for Zoom. Let's start and see if we can get the audio.
Thought I heard it for a sec, but now I don't hear anything.
Okay, so so it came through the speakers here in the classroom. So let me let's see here. I should be sharing computer sound, but let's see here. This is going to it says going to that, but so you heard it for a second, but not. I know there's a way to do this.
Must have just been through the. Probably just hearing it from the speakers.
From a microphone. Well, that's not good. So, I wonder why it should come over Zoom. I wonder if I muted myself.
Nothing yet. I can still hear you, by the way.
I think when you click share screen, maybe you have to like click share audio as well, or something like that. Like within the Zoom settings.
know I've done this before. Oh, maybe I don't need. Do that. And then share sound, share screen.
That will force me to write public
Works
class
great.
game.
Yep, that worked.
That worked? Okay. So I will start
A
over
little loud,
again.
but yeah, it worked.
Technical Bob.
Oh, it's time for the red-green refactor cycle. And I am in the red phase. I must write a failing unit test. All right. What test must I write that will force me to write public class game? Well, I'm going to write can create game. Game G equals new game. Oh, heavens. Thank you, IDE. Helpful IDE. That's enough of that. Heavens to Murgatroyd, that doesn't compile. Well, I must make it compile. So now, I'm going to create the class game. Yes, in the current package, there it is, the class game. And if I go back to my test, oh, look, the test passes. It's time for me to go to the green phase. I am now green. And in the green phase, it's time for me to refactor. Is there anything I can refactor here? No. Nothing to refactor. Very good. Then I am done with this test. I am passing. Lovely. Back to the red phase. The next test, well, I know I want to write that roll method. All right. Test can roll. Oh, heavens, I need a game. Game G equals new game. Lovely. G dot roll. What should I roll? Well, let's roll a 0. That doesn't compile. Okay, time for me to focus on making it work. I'm going to create the method roll. Ha! Look at that, roll. And it should take a pins. This is lovely. And I believe that will pass. Because I'm not actually testing anything. Oh, time for me to refactor. I've got a passing test. What's to refactor? Oh, goodness, I've got duplicate code here. Duplicate code. Well, I better take that and refactor that out. I'll create a field named G. I will initialize it in the setup method, which of course I don't have, but this will create. I'll keep it private. Lovely. So now I've got a nice setup method. It's going to create the game. It'll put it in the private field G. Can create game is now empty because, well, it doesn't do anything. And I think I can get rid of that line of code in can roll. And all of this should still pass. It does. I think I can get rid of that empty test now. This is common, by the way. You write a test just to delete it later. Lovely. Next most interesting test case. Back to red. Well, what can I make fail now? Oh, I got to write the score function. But I can't call score until I roll a complete game. Okay, so here we get into some of the technicalities of test-driven development. When you must write real code, you write the simplest real code you can. In this case, I'm going to have to roll a complete game. What is the simplest, most degenerate complete game that I can roll? A gutter game. Let's roll the gutter game. Okay. 4 int I equals 0, I less than how many balls in a gutter game? 20. I plus plus. G dot roll 0. That will roll 20 zeros. That is a gutter game. And now we will assert that the score is 0. Oh heavens, that doesn't compile. I must make it pass. Excellent. I will make this compile. It should return an int. I'll have it return a -1 because I still want to see it fail. It should fail. Yes, and now I will make it pass by returning a 0. This is stupid, but it's also easy. And I have now seen my test both pass and fail. I know my test works. It cost me nothing, but I now know that my test will fail if I don't get a 0. Well, that was nice. What is the next most interesting test case? Or is there any refactoring to do? No. Next most interesting test case.
Okay. So let's see. Stop sharing computer sound. So what did you observe about what we just saw? So Uncle Bob walked us through a portion of a test-driven development coding session. What were some of your takeaways? What were some of the things that you saw? What questions did it leave you with? If you want to participate, you come off mute. Raise your hand on Zoom so we know. Joshua, I saw you came off mute.
One of the things that I took away from that is that you don't have to have everything complete before you start writing tests. So you don't have to wait until your full application is done, like project phase 10. You could start doing from project phase 0 and just test small things incrementally. And if one of the tests is useless, you can always delete it as well.
Yeah, no, a great observation. I think that really is one of the core tenets of test-driven development is that you work in small increments, right? You write the simplest test that you can, and you build up from there, and you represent all your functionality as tests before then you implement the logic. Great. Other than the ridiculous hat, was there anything that surprised you about what you saw? Vidya?
Yes, so my observation from this was that with every implementation, there should be a parallel testing. So every segment has to be tested before we move on to the next part, because that will help us both save time and as well as, I mean, retesting or redesigning comes with a higher cost. So we can just cut on that if we are doing it parallelly. So that was
Great.
my takeaway.
Yeah. Talking about design and sort of, getting an opportunity to evolve it as you go. Great. Here in the room? Yeah, small increments. So just writing, a couple of lines of code under test and then a couple of lines to test the code. Nice. Casey, you had an observation?
Yeah, I thought it was interesting that he was writing filler code, like just telling his function to return 0 when we know that that's not the end functionality, just to get a test that passes.
That's right. And so then follow-up question for either Casey or somebody else. Why do you think he did it that way?
Because he's setting up the structure for the tests. And then now that he's got something that passes with a return of 0, now he could say, do a bowling game where you get a perfect score. And then that will no longer pass. And so then he has to write code that gets to that score.
Exactly, right. And that's the whole idea of red-green refactor, is that the first thing that you do is you write a test that fails. You want to see your code fail because you know it's wrong, and then you make the code, then you change the code until the test passes, and now you know you've implemented the functionality. And then that's the green, and then you look to say, is there a way I can improve the code? Polish it up. You saw he had duplicate code, he moved it into a field. Is there a way that you can improve the names now that you know more about what it actually does? That's what refactoring is all about. We'll talk more about that later in the class. Great. Other observations here in the class? Okay. So yeah, his observation was, oh, he's, Uncle Bob was just sort of like, coming up with test cases off the top of his head. Is that the way you do it? Well, sometimes. What I like to do is do a little bit of brainstorming. And as a matter of fact, we'll do that next week, where we will, as a class, we'll brainstorm some potential test cases, sort of give us some framing. But then you start writing code, and then as you write code, you'll think of, oh yeah, I also need to test this case. I also need to say, oh yeah, well, what if this happens, right? And so then it's kind of a ping pong back and forth from coming up with new test cases to then implementing those test cases and then making them pass. Yeah, good observations, great. Other thoughts? The command of the IDE, yes, using your tools, and I hope you'll be equally impressed with my IDE skills. Whatever, but yes, I mean, you saw how quickly he could work because he had mastery over his tools. This is another thing that I've learned, where it's worth investing in understanding an IDE, using the keyboard shortcuts, understanding a tool like VI or Emacs, even though if you don't use it every day, it's like, wow, you can go so much faster if you sort of know the things. And this is what you build up over time in your career. Mark, I see you have your hand raised. Have something you'd like to contribute?
Yeah, totally. I don't know if there's any meat on this bone or not, but something with like tests and test-driven development, it's always been difficult for me is like when my project scales a little bit, like or trying to do something in a large code base, like dependencies and also getting sort of stuck in this like just coding in general. I guess I get stuck in this thing where I try to start small, but my brain keeps going bigger and bigger. Like, oh, this is dependent on all these other things, so now I have to think about this and this and this. And so yeah, do you have maybe anything to talk about there in terms of like how to think about that kind of stuff with TDD?
Yeah, it's a challenge, and what I learned over time is like, oh, never really taught me how to write tests, and it's like, oh, I kind of wish they had. And so then the quickest advice I can give is 3 words: given, when, then. And if anybody's studying anything called like behavior-driven development, you'll see this reference there also. So when you think about a scenario, or really a test scenario, or really any expectation that you have, think about like when you expect something to happen. Well, there needs to be a scenario, a situation, and that's the given. So it's like, given I am in this current state, when I perform some action, then I expect something to happen. And just framing things that way helps me understand my test. Like, well, first thing I need to do is I need to do a little bit of setup to set the stage, and that's the given. And then I need to perform some operation. So I call a method, or I, input some data someplace. Okay, that's the when. And then I need to express like what I expect to happen, and that's the then. And for me, just using that pattern over and over again as I try to articulate what my expectation is, that's helped me write test cases. And I've found that pattern applies at the large scale and also the small scale. And so then oftentimes I start with like the largest, here's what I expect my program to do in the whole, or in the large. And so then just like given, when, then, coming up with all the scenarios there. And then when I implement the tests, I often start out with like sort of the coarse grain test, which may be an integration test, like as you were saying. It might start up multiple things, processes, and they're talking to each other and everything like that. But then I see it fail. And then what I start doing is I go, I get more and more granular until I'm at something where it's like a unit test. I can say, well, great, this particular unit, which is like this one little object inside this whole big thing, but I know this needs to behave that way. So that's what I found to be effective for me. And I think in this course, you'll have the opportunity to explore those kinds of things, not in a grandiose environment, but still in a large enough environment so that you'll get appreciation for when you should use an integration test or when you should use a unit test. Great question. Okay. Before we write a couple of unit tests, any more questions? Nope. Oh, I said there are a couple of things in. There's a question in chat. Is it bad practice to have JUnit code in the same Java class as the actual code? Yes. Your tests. So actually, that's actually a great segue to looking at the code. So here we are in IntelliJ. And as I pointed out before, we keep our test code separate from our production code, our main code, our code under test. Because what I want to ship to my customer or what I want to deploy to my production environment is the main code. I don't want to deploy my tests. I mean, sure, there might be some validation and stuff, but that isn't like the code itself. That's the things that test the code. Very, very important. And in many respects, you want to treat your test code the same as you would, if not better, than your production code in terms of making sure it's under version control, making sure it's easy to read, making sure that it's refactored and is good code. But it is and ought to be separate because you don't want to be deploying your unit test framework into your production environment, right? That's just wasteful, and that opens up vulnerabilities and just makes things more confusing and more error prone. So you want to have a nice separation of responsibilities between your main code, your code under test, your unit tests, and then your integration tests. Here in the student class, and we'll dive more deeply into this next week, but I just wanted to go over what's here. So the student class is very simple. It's from what's created here when you create the project, you have a student. Each student has a name. A student takes some classes. Student has a GPA, and the student has a gender. And student inherits from human. And if you watch the, I guess it's the object-oriented programming lecture, I have this whole class hierarchy of like humans and mammals and animals and things like that. And so a student is a human, and every animal says something. And in the case of students, all students say this class is too much work. And there's also a toString here, and then there's a main. I think let's write our first unit test, and actually let's test our says method. So all students should say that this class is too much work. So we'll write a test for that. Here is actually it comes out of the box with one test that verifies that a student with a given name, when you call the getName method on that student object, that it is equal to the name. Actually, and let me explain here what's going on. This is a good example of given, when, then. So the given part here, and I'll just add some comments here. So given that there is a student named Pat, and that's really this part, and then when Pat's getName method is invoked, or actually when Pat's name is requested, then Pat's name is Pat. Right, and so that's like the English way of saying what this test does. So the first thing I do is I have this variable called name, which represents the name. And I pass that name to the student constructor. And so I'm going to do a split screen so we can see all the code here. So I'm going to do a split and move right. So the test code is over here on the right, and the code under test, the main code, is over here on the left. When I control click on student, or when I say, it's not control click, command click B. Oh, and by the way, down here at the bottom, I have my IDE configured to have this little pop-up to show you the keyboard shortcuts that I'm using. So command B goes over here to the declaration, move the cursor over to the declaration of the student constructor. You pass in a name of Pat, an empty thing of classes, a GPA of 0, and a gender of doesn't matter. And all this does right now is it sends name up to the superclass, which if you go and look at that, you'll see that human has a name. Oh, actually, a name here is inherited from animal. Oh, I should probably make that private at some point. But anyway, and so that sets the name associated with an animal, and every animal has a getName method that returns the name. And this is that name method, the getName method that is called right there. So that is the given part. That is creating the Pat instance of student. And now when we call get name, we expect it to be, we want to say, hey, listen, I expect that when I request Pat's name, then the name of Pat is Pat. And so then I use a method called assert that. Now, Eagle Eye viewers will remember that that Uncle Bob used a different thing. He used assert equals. That is an older style of making assertions in JUnit. The assert that actually comes from a library called Hamcrest, which gives you these things called these assert methods that take these things called matchers that allow you to have what I think is a much more readable syntax of saying assert that pat.getName comma equal to name. It makes it clear. It also provides you with much better error messages when something when the assertion fails. But what an assertion is basically saying is like, I have an expectation and I want to encode that expectation in a statement and assert that. So I want to say assert that pat.getName equals to name. So this right here is a unit test. It's just a plain old Java method that has been annotated with this @test annotation. And IntelliJ knows about these tests and will let you do things like run the test. So over here in the left margin in the gutter here, you can click on this and say run the test. And what that does is that IntelliJ will then build the source code and run the test. You can see down here it's building and it just ran the test. And it said, great, everything passed because it said, yep, one test passed. You can also show the test that passed. It said student named Pat is Pat. So, okay, this test passed, and that's good. But now let's write another test. Let's write a test for, let's see here. And we'll call it all students say this class is too much work. And so I'll do that given then. So we'll have our student name Pat again. So given that there is a student named Pat, and we'll say when Pat is asked to say something, then Pat says this class is too much work. And so the way I do that, or rather how I express that, is I say assert that Pat dot says equal to this class is too much work. Right. So when I invoke Pat dot says, this will return a string, and I expect that string has the value this class is too much work. So now when I run this method, it fails. And it fails with an unsupported operation exception saying this is not implemented yet, and it prints a stack trace which says what code was executed when that exception is thrown. You go and look at the source code, and sure enough, you can click on this line right here, and it takes you right to it, and it says, oh yeah, right. When it says it's invoked out of the box, it throws an unsupported operation exception because I haven't implemented it yet. Aha! We have a red test, right? This is the red-green refactor. And so now I need to make this pass. How do I make it pass?
Okay. Oh, sorry.
Sorry, what was that on Zoom?
I thought you were asking a question, so I was going to say to get it to pass, you return a string that says this class is too much work.
Yeah. So I make that change over here. I'll run my test again. And it passed. Now I probably want to run all my tests again because I changed the code. Okay, everything passed. Okay, so now I had my red test. I made it green. Now I'm looking for opportunities to refactor. Does anybody see any opportunities to refactor?
I don't know if this is correct, but right here you're saying pat.says. Could you maybe create a method that says pat.getSays and then like have another method like kind of like what you did for the first one, like pat.getName? Or would that be
having
unnecessary?
well, I look at says as sort of a verb that it does. So it's not so much a property of Pat, it's just like what Pat does. So I don't know if renaming that method would necessarily bias anything, but let's give it a try. Let's see if we like the code better. Oops. So we can go to the refactor menu and we can say rename. And since the cursor is on the says method, it'll now, oh, it's inherited. And you know what? I guess I really can't change that too easily. So that's not so much a good, it's not a terribly good candidate for refactoring. But I kind of like where you're going with that. So maybe we can use it someplace else. Alex, you had something here? Oh, where is our duplicate code? So he said, oh, you can delete the original test. Yeah, it's not really duplicate code because the when and the then are different, but I think maybe you're picking up on that. Okay, so yeah. Okay. So yeah, maybe we can. You could do multiple assertions in a test, although there's a school of thought that says, it's kind of a purist school of thought that says, well, no, you should only have one assertion per test. That way, because let's say you had 10 assertions, if the first one fails, you'll never evaluate the other 9. And yeah, you'll know where it fails and stuff like that. Oh, it looks like there's some stuff going on in the chat. What are people saying in the chat? Redundant code, same student with the same input-ish. Yeah, I mean, I think what we're saying here is that, look, I've got, I create a pat here, and I create a pat here. We're doing that as a duplicate. So how about, so what I want to do, I'll do the following, and I will make it big so we can see it. So I've got this code here, and I've got that code there. So I want to say, instead of having that big long constructor with all those parameters and stuff, I'm going to use a refactor menu, and I'm going to say extractor introduce. I'm going to introduce a method, and I'm going to call it create student named. I'm going to pass it the name. And so you see what IntelliJ is doing is that it's creating a new method there on line 29 called create student named. And I passed in the name. So it took the code that I had highlighted it, moved it into a method, and it noticed, oh, look, you've got a duplicate occurrence there. Do you want to replace that with a call to that method? Yes, I do. Thank you very much. Poof, and there you've got it. And so now I've got code that's a little easier to read. And let's see here. And in here, here I want to have the variable name there and that. And so then, but here I have name equals Pat, and I have and I don't use that name variable again. So since I only use it once, and I guess it's not terribly relevant here, I'm going to do another refactoring where I can inline this variable, which I can take the value of it, and then it just moves it down here and removes the variable. And so what I've done is, and actually it doesn't need to be a student named Pat, that there is a student. And so actually the name doesn't matter at all. I can just call it student. Who cares, right? And now I'm going to run my test again just to make sure that my just to make sure that my code passes. Nice. So, and Alana, I see your questions. I'm going to get to them right now. But first, I've made some code. I've made some changes pass, and I like to when I have tests that are all passing, I kind of want to I want to put things to rest. I'm going to be changing things. So what I do is I like to commit my code after I add something, add a test, and make it pass, and I like to commit it. So I'm going to go over here to my Git tab. It shows that there are 2 files that have changed, and so I am going to commit this code. And I'm going to say validate that all students say this class is too much work. I'm going to push that up to GitHub. So meanwhile, there have been a couple questions that have come in the chat. What is supposed to happen when an invalid gender is given? And then that made Alana think of, hey, is the input verification supposed to happen in the student constructor or in parsing the command line arguments? Those are great questions, and those are the things that we get to explore as we write more unit tests. So right now, I don't know what the right and wrong answers are, or I don't know what the good and better, the good and not so good answers are to that. And these are the kinds of things that we can explore as we write our code. But yeah, I think some of the tests that we should write in are about validating the input that's in our program. And those are things that I want to explore next time. So just today, I wanted to give you an idea of what it's like to write unit tests, to see things like just sort of syntactically how they work with things like the test annotation and the assert that. Please go and review the JUnit lecture that goes into much more detail here. Because this will serve you really well in the course. And actually, next time we'll talk more about what some of the requirements are around testing. But any fundamental questions about JUnit and unit testing and test-driven development?
So, is there a particular reason you think?
Oh, yeah. Why am I using var instead of student? No, I think I just wanted to show it off. Oh, actually, I think I know what it was. Way back when I wanted to make sure that everybody was using the right language level, and so this was introduced in, I don't know, Java 9 or something like that. But no. So yeah, actually to this syntax. So notice how we have string name here, and so this is saying, hey, this name variable is a type string. And but the pet variable has a var type, which means it has an inferred type, and the IDE is helping you by saying, oh yeah, it's inferred as a student because create student name returns a student. But no, there's like no reason. I think sometimes it just makes it a little easier. I mean, we know we're testing a student here, but like for instance, actually, so I don't want to call this Pat. Actually, I messed something up here. I want to call that student. And I think there, I mean, it makes sense. It's like, oh, look, student, it's of type student. So I think that's plenty readable. I think, yeah, one could argue that maybe up here, this should be of type student. No, it's more for demonstration. Thanks for noticing, though. I think that's maybe not the strongest example there. And now I can do it again. So make it more clear where a var type is helpful. Nice. Okay. Let's start talking about the assignments that are assigned today. So the first one is the beginning of our projects. So in advanced programming with, oh, sorry, there was a question that came in on chat. Would it be bad practice to create a class member for our test student to run tests against? Bad practice? No. You saw Uncle Bob do that with the game. I guess it all depends on how many tests will really be able to leverage that one student. I think my preference is, creating an object that's fast and cheap and things like that. If you're testing something that is expensive to create, I don't know, it connects to a database or goes and reads a bunch of data. Yeah, maybe you just want to create it once per test. I don't think I really have a strong preference. I would encourage you to experiment with storing test data in variables versus just creating there in the method. I find it's easier. It's easier for me to understand it when everything is created right there in a method. But that's just my personal preference. I don't think it's really a clear case of good or bad. Okay. Let's talk about the phone bill application. So you'll be working on a five-phase project where you model a phone bill, right? You get phone calls, and your phone bill keeps track of all the phone calls that you made and that you've received. And in this project, you're going to lay the foundation for that by creating the fundamental classes that you'll work with through the rest of the course: the phone bill and the phone and the phone call classes. And the intent here is that you get an opportunity to write some new classes, to extend some of my classes, and do some more and start working with the command line. And parse things on the command line. So there's some code that I provide you that are in my package, which is edu-pdx-ts410j, and that and there are two abstract classes. So as you may recall, in Java, an abstract class is a class that cannot be instantiated. So the whole idea is that before you can really use it, you have to subclass it. So it has some state and some behavior that you inherit, but then there's more things that you need to do with it in order to use it for real. And so I've created two classes, abstract phone bill and abstract phone call, that you are going to extend in your classes called phone bill and phone call that are in your package. And let's see here, I don't remember what the footnote is, but anyway, and your classes must be concrete, and so they must implement all of the abstract methods that they inherit from their superclasses. A phone bill has a name of a customer to which it belongs and contains multiple phone calls. And a phone call is initiated by a person that has a given phone number, and it's initiated at a given time, and it's received by a person with a given phone number, and it terminates at a given time. For this first assignment, it's sufficient to model all of this data, including the phone numbers and the date times, as strings. That's fine. In future assignments, you might use other data types, but strings are fine for now. There are methods called get begin time and get end time, which you can just ignore. You don't need to do anything with those for this project. So you have two domain classes that are modeling a phone call and a phone bill. There's also a class called Project One, which has a main method. So a main method is where a Java command line program starts executing. And it's just like the main in C or C++, or I guess Python has one too. What it does is it receives the arguments from the command line, and it parses the command line. It creates a phone bill, a new phone bill, and a new phone call, adds the phone call to the phone bill, and optionally prints information about the phone call by invoking its toString method. So the command line interface for Project One should accept the following. Let's see here. Have some optional arguments followed by some required arguments. Sorry, optional options followed by required arguments. I don't know if I said that right or not. So the args are the customer name, the caller number, the callee number, the begin time, and the end time. And those may be preceded by an options of either -print, which will print the description of the newly added phone call, or print something called the README, which we'll talk about next time. It just prints the README and it exits. And note that when you enter dates and times, like for the begin and the end, they should be in the format month, day, year, 4-digit year, and then hours and minutes. The customer argument is always one command line argument. So if you want to have a multi-word argument, you need to delimit it by with double quotes on the command line. However, the dates and times, they are not quoted. So the begin time takes up 2 command line arguments, as does the end. And so here are some examples of valid dates. And phone numbers have the form 3 numbers, -3 numbers, -4 numbers. So all in all, that is the behavior of the project. Whole bunch of footnotes here. I'm trying to think if there's anything. Oh yeah, that I want to highlight. So please note, and this is something that students have gotten wrong in the past, and that's why there's a footnote about it. The only way to send input into this program is via the command line arguments. Don't try to read input from standard in. This is not CS 101. We don't read from standard in. Don't assume there's a file that you read it from. I don't know where the kids get these ideas. It's like, no, just from the command line. It's okay. That's it. Don't make things more complicated than it needs to be. Question, yeah? No external file for this assignment. Don't worry, files come next time. This assignment is actually kind of dumb because it is a training wheel assignment, right? It's getting you used to using the IDE, getting you used to writing unit tests, all that kind of stuff. And so then if you're kind of rolling your eyes like, this is easy, it's like, well, this is not the interesting part, to sort of like implementing this functionality isn't necessarily the interesting part. It's everything that you do around it to start developing Java programs. One phone call, one phone bill, all lives in memory, nothing is persisted, right? Super simple, right? Yeah, have it done in 15 minutes, right? And so then, yeah. You may parse the phone number however you want. If you want to use a regex, great, use a regex. If you want to use, want to hand roll it, that's fine, but you do need to validate it, right? So, yeah. Again, anyway, et cetera, et cetera. Oh, yeah, we'll talk more about the README next time, but there is a handout there if you want to read up on it now. And, oh yeah, and months and days can be 1 or 2 digits. The year should always be 4 digits. So, error handling. Something that my previous students have, some of my previous students have expressed shock as like, wait, all you're really testing here is like command line parsing and error handling. Yes, that's it, right? This first project is really, about how do I write a well-behaved command line program. So your program should exit gracefully with a nice error message. You shouldn't see a stack trace. Just be clear to what the user is saying when unreasonable input is provided to the program. So for instance, something is missing from the command line, or the format of a phone number, or the time or date is incorrect. Things like that. And more. I'm not going to tell you every scenario, but it's things like this that your program should respond to. Note also that when no command line arguments are provided, you should get a nice helpful error message. You should not get like a stack trace or an exception or an array index out of bounds or something like that. Please think of all of the all reasonable error conditions. And if you have a question, ask on Slack. There is a Project One channel for all questions. Project One. Question, yes. Project Zero, the student is just a toy. I mean, I use that as a demonstration. You may or may not want to experiment with it on your own. Honestly, I think I would start with Project One. It's not, Project Zero is not required or anything like that. I don't even know if you can submit it these days. But anyway, I'm not going to grade it. It's really just for me to show you something that looks a little bit like your projects to give you an idea of how you might want to approach it. Okay. So let's take a look at, I'm not going to walk through this necessarily. Well, yeah.
I've actually got a question really quick.
Yeah.
So when I was working on Project Zero for a little warm up, I had an issue where Maven kept throwing an error saying that I couldn't throw exceptions in the main function. So
yeah,
what I ended up doing was basically creating a different function called create student, and that did all of the error handling by throwing exceptions with custom messages, and then wrapping it in a try catch block and calling it in the main function. Is that how we're supposed to do it?
I think it's a fine solution. So what Alana's saying is that one of the things that I tell folks is that the user should not see exception stack traces. But this is something that, like, time and time again over the years, students have not, have had command line programs that like spill over a stack trace. I know as a developer that's very helpful, but as a user, it's like, what the hell is this? Right? You don't want to see that, right? I mean, I'm sure everybody's used like some website where like, they get like the you know, the Microsoft IIS error page, like there was a 400 or there was a 500 error, and like here's like some internal stack tracing, or like this is scary. Users don't want to see that. And so in your integration tests, if you call your main method with a certain input and an exception is thrown, so it's not caught in the main method, the test will fail. And with a very specific error message saying, "Hey, listen, your main method shouldn't throw exceptions because that's bad form." Because you don't want to lose credit, you don't want to lose points when the grader grades it, because there's a stack trace, and so then the integration test framework is nice enough to be extra clear about what would happen. Good question, Alana. Let's see here. So another question. So project 1 will only be creating 1 phone call per phone bill. Oh, sorry. Yeah, I guess we'll all do that. Nice. We covered that. Okay. So let's create this code. So here in your repository, there is a create first project script, and assuming that you've run the survey program, then you can run create first project, and it'll go off and it will create the beginnings of a phone bill project. So I can do a git add phone bill here, and I'll look at status again. So I also want to add the top level pom.xml. It created all sorts of good stuff. And we will take a look at this momentarily. But first, I want to commit it here. Oops. Git commit at the beginnings of a phone bill project. Cool. Push that up to GitHub. Okay, now if I go back to my IntelliJ and I look at my project, I think I need to do a refresh here. So if I refresh it, now it's got a phone bill directory, and Maven is syncing, and now it turned it bold, meaning it recognizes it as this is my site, yeah, as a Maven project. And so now let's take a look at it. It's got main. Ooh, it's got all sorts of good stuff. It's got Java classes. It's got some Java doc stuff. It's got resources. Oh, it's so good. We'll talk about that next week. Let's just get rid of this tab right here. Command F4. And so now it's got wow, it's got all sorts of good stuff. It's got a project 1. Oh, those are the tests. No, wait, no, this is right. This is it. Yeah. Right. So it's got a very simple main method which creates a new phone call, and then it prints missing command line arguments to standard error, and it prints all of the command line arguments to standard out. Let's just go take a look at how that works. So if I go to the phone bill directory and I do a Maven W clean, which I really don't need to do, I haven't built anything yet. I do a clean verify. That will build all the source code for the phone bill project. It'll run all the tests and just make sure, and it'll create something called an executable jar file, which allows you to run the main method real easily. So we'll just give it a moment or two to do that. And say java.-jar, and we say in the target directory, it's going to be the phone bill.jar. And when it says missing command line arguments, and when I have 1, 2, 3, it prints missing command line arguments 1, 2, 3, which is exactly what this main method does right here. So it prints missing command line arguments and then 1, 2, 3. Cool. And so this is how you run your program from the command line. By running the executable jar, it actually brings in a whole bunch of dependencies. So you've got one artifact to execute against, as opposed to having to set up your class path and things like that are really confusing. So this makes it pretty easy to execute your command line program, because this is what ultimately the grader will test. The grader will send inputs to your command line program, and they will assess the output given those inputs. But also in here, so you've got the beginnings of your phone call class and your phone bill class. There's a lot more here than I remember there being, but okay, fine. So I guess you don't need to create those after all. I've created them for you, but you need to fill in the blanks. on a lot of this stuff. And then there are tests. So I've got, oh, nice. Okay. I've got, we'll talk about the README next time. But here you've got here's a simple test for your phone call. And by the way, you can ignore the text dumper and text parser stuff. Those are part of project 2. Those will help you with project 2. You don't need to worry about those here. But here is an example of a couple of unit tests. You can run them right now out of the box, and they will pass. But one of the first things that you'll need to do is update these unit tests to do something a little bit more interesting. Because you'll see right now, like this test right here, you create a new phone call, and when you call get begin time string, right now it throws an unsupported operation exception, right? Because it hasn't been implemented yet. So one of your first jobs may be to implement that and have it do something reasonable. And same thing for validating that at the beginning, that initially all phone calls have the same callee. You want to, so right now all callees return the same value. Well, you'll want to have that be something, have that be something more interesting also. The bottom line with these tests is that these are meant to be example tests. And so like here again, the comment is like, you probably need to delete this. I have these in here to just validate that yes, out of the box, the project will build and that there are interesting unit tests and stuff like that. Your job is to replace these with unit tests that are more meaningful as you build out your project. So this is what you get out of the box with project 1. We'll talk about more things next week, like the integration tests, like the text dumper and text parser. All of that will become apparent to you, but you can get started on it now. And I encourage you to study the assignment, start poking around with some things. It is due in 2 weeks. It is due July 6th, yes, which is in 2 weeks. Next time we will also talk about how to submit your projects, but any questions on project 1? Correct. The begin time and begin end methods actually use the Java util date class, which is something we'll talk about. Is a week 2 topic, and so here you don't need to do anything for project 1. Also. Okay. So are there things, are there third-party libraries that you can depend on? So you can use anything that's available in the standard Java libraries, which includes regex. So yes, regex you can use. And so yeah, I encourage you to go. I can't remember what's in the lectures about regex. I might have something, but certainly go look at Stack Overflow to figure out regex. No problem like that. Remember, Stack Overflow is fine for like researching the projects. You just can't use it on the quizzes. Wait, there's more. But you may not leverage additional external third-party libraries. So you can't go find like Apache Commons easy command line parsing library. No, we can't use that. So you have to write your own command line parsing library. Yes.
Like regex expressions, pretty standardized.
Yeah.
Something like that. Like if I have blah blah blah, you can parse it. That's like trigger
Oh, right. So the question is like, hey, there are well-known regular expressions for for parsing phone numbers or dates or whatever. And if and hey, if you find one that's Stack Overflow, or if you just happen to guess one that's common, is that going to set up the plagiarism detector? Probably not. So I think you're okay. Yep.
If it does.
Well, the first thing I do whenever there's like something that smells like one student copying another, is I reach out to you and say, hey, I saw this, what's the story? And actually more often than not, it's like, I don't even know that other person, and it's legit, right? It's actually the rare case where I get some excuse like, oh, I thought it was okay to work together. It's like, what? Yeah, so no. Yeah, what? Well, yeah, right, yeah. So here again, here I feel like it's sort of like legalistic to have to say don't cheat, but it's like if I don't, the point never said I couldn't look at arg, right? Anyway. Cool. Other questions on project 1? Nope. Okay. Mm. Yeah. Oh. Yeah. So what Alex is pointing out is that there's sort of like a very important and maybe kind of subtle step with using IntelliJ. When you open up IntelliJ and you tell it to open a POM file, it must be the top level POM file. So the one from the top level, Portland State Java Summer 2022, or the root of your checkout. That's the one that you have to open. That is the parent project. And so as you can see here, it's got modules for your student and your phone bill. That's what tells IntelliJ. It's like, oh look, this larger project consists of these 2 submodules. So that's why you need to open it. Oh, you have to go all the way to the project in order to build it? Yeah, you might want to start over again, or well, sorry, not start over again with everything, but with yeah, and by the way, it is it's very common because again, unfortunately, these steps are. I mean, is this something I could automate? I don't know. There are just there's some peculiarities, and you have to be rather methodical about the order in which you do things in. So, for instance, there's this paragraph here that talks about, oh, hey, you need to run Maven verify before you open the project IntelliJ. Otherwise, it won't be able to find libraries. I don't know if that was your case, but if IntelliJ is like messed up beyond all belief, quit IntelliJ, delete all the IML files, delete the .id directory, and start over again. As long as everything's in GitHub, it'll be fine. IntelliJ usually gets it right, but sometimes it gets it wrong, or you do things which seem to make sense, but it's a little out of order, and things get messed up. It's a problem, but you are not alone. We've all been there. Okay. So that is project 1. There's another project that is assigned tonight, and that is the Java Koans. So I don't lecture a lot about the Java syntax. I used to. When I first started teaching the course, we spent Grandpa's telling stories. Like when I first started teaching, like I had an overhead projector. I had those like slide. You don't even know what I'm talking about, do you? So okay, yeah, right, yeah, maybe so, right. So it was literally this box that had a little arm, and it had a mirror in it, and there would be this light that would shine through what it calls transparency. So it was a piece of clear plastic, and your writing would be on it, and then be projected onto the screen, right? So this was like 2000, right? And oil was cheap back then, and so was plastic. But anyway, and so I used those, and like my class was, Professor Dave up here, just lecturing on Java, slide for slide for slide. Sorry, where was I going with this? I guess it's right. Oh, and I used to start out with like this big long review about object-oriented programming and the Java language syntax because students hadn't had it yet. Well, in a couple of years, like a couple of years later, in 202 or whatever, everybody got an introduction to Java. Okay, good. And so then I didn't feel the need to go through and review, here's what an object is, and here's what an interface is, and here's what extends means, here's what final means. I think you've all been exposed to that. And so I don't feel the need to invest a lot of time here in class to teach you that, or even to have like, deep and involved lectures on it. Even though I have the slides, I don't have a screencast on it. I've invested in that. But instead, but there are a lot of aspects of the Java language that either you haven't seen in a while or maybe were never familiar with in the first place. And to help you explore that, I have these what I would call the Java Koans, which is a project in which you look at very little code snippets, which are actually kind of like unit tests, and you fill in the blank. So it's like a Mad Lib type thing. So and we'll see one in a moment, where we basically say, hey, I'm performing some operation in Java, and what's the result of this operation? And you fill it in, and it tells you whether or not you got it right. This is not my work. This is work that is open source and that I use. There's a guy named Matty B, who I think is in Chicago. Last time I corresponded with him, Matt Bentley, and he came up with this, and a couple other people have contributed to it, and I've leveraged it for a number of years in the class, and I've found that it's really a quite effective way to learn about the Java programming language in little steps. But there are a lot of little steps, and so that's why this isn't due for like another 4 weeks, because my intent is that you'll just I'll show you how to get started tonight, and you'll sort of like do a little bit every day, or maybe every couple of days do a little bit more. If you wait until the end to do it, not only will it take you a lot of time, but you really won't get the lesson because it'll be going through too fast. These are meant to be sort of savored is not the right word for it, but it's like take your time and enjoy it and try to understand what the cone is telling you. So what you do is to get the cones, you run the create cone script from the project. Once again, we have a script and it creates things. Oh, there's a chat. Someone's in Arkansas and it's 11 o'clock. Have a good night. So now I'm going to add the cones. I'm going to add pom.xml. There are a lot of them. Added Java cones. Push them up. Oops. I want to pull. I want to push. Nice. And now if I go back to my IntelliJ and I synchronize, there's a cones directory and Maven is syncing. And okay. So it looks like it's got that. So I've created the cones, and now the cones run a little differently. How you interact with the cones is that you run a Java program, and it sits there and looks at the source code, and as you edit the source code, it will compile it and tell you whether or not the cone has been successful. So let's take a look at one of the cones. Let's see. Or actually, no, sorry. We should run the program first. And the way you run the program is by saying maven w exec Java. Let me do that from the cones directory. So it's like runs a little Java program, and it gives you advice on what to do. And it says, open up the file, which is called aboutcones.java. And there should be a method starting with @cone called find_about_cones file. Look within it for your first lesson. Once you have solved that, save the file and check back for your next lesson. And then let's see here. Ponder what's going wrong in the aboutCones classes find_about_cones method. Line 11 may offer a clue as how you may progress. Now make haste. Okay. So the first thing, open up the file aboutcones.java. Okay, so let's go here. And we can say navigate to file and about cones. Okay, there it is. Okay, here it is. And it said line 11 may offer a clue. Let's go find line 11. This got collapsed here. And it said, aha, find about Koans file. Fail, delete this line to advance. Well, so what should we do? Delete the line. We delete the line, and then we go back to our command line. It notices, IntelliJ writes the file when it loses keyboard focus. And so, okay, it ran it. And now it says, okay, a Koan is considered complete. Oh, by the way, it told us, oh, we got 1 out of the 269 Koans that you need to do. Let's see here. Someone said, wow, exactly. They're probably doing the wow, not at the automatic compilation, but the 269 Koans. And so, okay, a Koan is considered complete when it no longer throws an exception. Often there is more than one way to solve a Koan, but only one correct way is often hinted at within the Koan itself or the comments appearing here. Ponder what's going wrong in definition of Koan completion method. Line 18 may offer a clue. Now make haste. How do we run it again? It's in the PDF. It is maven w exec:/java. You're welcome. Okay. From the Koans directory, yes, thank you. Yep, that's an important distinction. So you're inside the Koans project. That's where you run exec Java. So now it is saying, okay, when Koan is not complete, fail. So let's see here. It is calling fail right here. So what can we do to make this Koan pass?
Delete it?
Delete the whole thing?
No, just the fail line.
Okay. Yeah, we could, oops, let's get the keyboard focus. Yeah, we could delete this line. Other ideas? Set line 16 to true. Okay, yeah, Casey, you have your hand raised?
Yeah, set that to true.
Yeah, set it to true. Okay, I like that. To make as few changes as possible. Okay, now we set it to true. Compile again, and we've got 2 out of 269. Yay!
I hadn't looked at all the code. I should have seen that.
Okay. Oh, here's another good prompt. So the 2 underbars are an attempt to communicate the need to fill in an answer. So I was like, they're like, fill in the blank. Judging by context, what should 2 underbars be replaced with? And so with something going wrong, it's now in a different class, about assertions, assert Boolean true method. Okay, so now we will go to the, so we'll just look for the class, about assertions. Oh, yep, there it is. Okay, here we go. Let me close this out here. Okay, there are 2 possibilities, true or false. What would be here? So what should this be? True. 3 out of 269. Okay. Like the prior Koan, ponder, if you will, the power of simple assertions when verifying an object's behavior. Okay, so let's see here. Assert Boolean false. This should be, yeah, false. Okay. Just check back. I like to do a couple at a time before checking. Okay, assert null object. So actually, does it give us like little hints and stuff like that? A keyword in Java to represent an uninitialized reference is null. There are times when something should be null, and this assertion can prove that. So what should be here? Yeah, the value null. And so what this is meant to do is teach you about the keyword null and what it means. Sorry, what was that? Yeah, I mean, and so then this is the thing where like, yes, it's baby steps. That's the whole idea, and it's meant to help. And I found it to be really effective at helping you sort of recall the little things in context. And trust me, it gets a little bit more interesting, like the next one. So, yeah, I think you can run it inside the IntelliJ terminal. Yeah, actually, yeah. You know, I think I'm just old school, and so yeah, I've probably been using IntelliJ before it had reliable terminals. So yeah, I don't think to have a terminal inside IntelliJ, but you certainly can. Okay, so then let's see here. Assert null object reference. So what should the 2 underbars be replaced with here? Yeah, null. Yep. The interesting thing here is that IntelliJ is kind of like barking at you. It's saying, it's like, oh, hey, the value is always null, and some more things that should just replace some object with null, and now it's like, I think the cone reads a little better if you just make this change, but I think you get here, and this is like, these are just meant to be sort of played with, right? These are sort of like Lego pieces. These are the Play-Doh where you get to experiment with these because there's not a lot of functionality in these things. Okay, one more. Let's see here. So this is null, but what should there be if not a null value? So like what? Oh, like the number 1? Okay. Let's see what that says. Okay, yeah, I think that'll work. So the question is, does Java consider a 0 to be null? Let's find out, right? I don't know. Cert not null. Obviously not, because it passed and it says it is null. Yeah. Yep. Or we could just say up here, hey, is 0, do we think that's a null object? Actually, and this should be, we should probably call it null object. Sorry? Yeah, this should fail. Yep. We just lost some points because it's not null. Yeah. So anyway, so you know what? This is probably good enough for now.